transit operators who are in the private sector, like PW Transit, Talk Transit, agencies and organizations that operate buses and could operate these shuttles digitally on behalf of M4 transit agencies in the future. And I'd be remiss if I didn't note also that we have several of our academic colleagues on the line who are part of our National Smart Vehicle Cluster of advanced innovative research groups across Canada, which Elnaz will mention shortly. We have kicked off this year and we're already starting to see the deliverables from those projects, which we are integrating into the planning for this joint procurement. So with that, we're going to start off and move right through the agenda. As I said, as per usual, a lot of information to follow through. And I just did get a note, of course, from colleagues here. Lindsay, thanks very much for noting. Lindsay Wingington from the City of Toronto. We have government stakeholders from cities as well. And I should have noted, not just federal and provincial, but of course, several of our cities are online as well. And lastly, I should note also, we have our colleagues from the standards associations joining us. So Peter Glowacki, among others, who are representing from the standards side of the equation. All right, with that, we're going to move through the materials. First off, I'll just ask Lana if you can move to the first slide. For the first part of the agenda today, I'm going to take you through the high-level introduction to our joint procurement initiative. It comes after 3 years of dedicated effort by my team to really figure out what is going on in the autonomous smart shuttle domain, what is possible in Canada, and for those systems that have been deployed, what's the empirical reality of how they've actually performed? And can we mimic that in some kind of joint procurement that allows for moving more people over greater distances with less energy and advances transit and shared mobility over single passenger cars? So we're going to take you through this introduction before we deep dive into some of our research results and then come back up for a fresh breath of air at the end of the presentation to outline to you what some of the technical specs and parameters are going to be guiding this project going forward. Go to the next slide. So first off, what you'll see here is really an overview just of the automated and connected vehicle systems. I'm not going to belabor this point because most people on this call are experts already, but I do know we have about a dozen participants joining today who are from our transit agency members who have not participated in these sessions before. We also have several participants joining us today who are from their city groups who have not been heavily involved in smart or connected vehicles in the past and now are being asked to do so. So just by way of introduction, when we talk about automated vehicles, we are talking about shared mobility settings. So we're not talking about individual passenger cars. We are talking about shuttles, but specifically the automated vehicle systems that we will refer to are those systems that help the vehicle read its surroundings, the LiDAR, the radar, the cameras, the ultrasonic sensors, as well as those localization tools like high definition mapping, cameras, GPS, and magnetic markers. So that's what we refer to as part of the automated vehicle system and network of technologies for these shuttles to operate. Go to the next slide. From a deployment standpoint, what we're looking at is, of course, like everybody, the SAE J3016 standard, and we're really looking at level 4. And you'll see throughout today's discussion, level 4 is where we are focused. We are not pursuing level 5. We're not interested in level 5 at CUTRIC. That may be something down the road, but really what we're looking for is a high level of automation and likely in dedicated and semi-dedicated laneway. Now, where we talk about a human driver intervening, note that the SAE J3016 standard is really designed from an automotive perspective. When you put it in the perspective of shuttles, we're not talking about there being a driver. The whole intent here is to have driverless shuttles on routes that don't have buses right now. We are talking about possibly a digital control or operations room being able to intervene to shut down the unit or redirect it, or a possible conductor on board that may be a personnel or a user or rider services support individual. So we're taking J3016 and interpreting it always in light of shared public transit oriented smart shuttle deployment, not in light of passenger cars operating in mixed traffic on any road in any condition. Go to the next slide. From a connected vehicle standpoint, when we talk about connected vehicles at CUTRIC, we are really specifically talking about the V2V, vehicle to vehicle, vehicle to infrastructure, and vehicle to everything communications. So we're really focusing our attention on the onboard units and the roadside units, the extent to which the communications between these vehicles and their surroundings as connected vehicles, it can be standardized, interoperable, and made to be boilerplate, RFP or procurement ready. One of the large challenges we'll talk about that we've experienced in the last last few years is the lack of standardization for public sector, or rather public fleet and transit fleet facing autonomous and connected vehicles. So really getting to V2V and V2I systems that are interoperable for these vehicles in a transit setting, including the OBU and RSU units that may need to be invested in by the city or the municipality as part of this initiative. We have for a very not long number of years, I would say maybe 2 years in our perspective, that's quite long, dealt with this whole issue of DSRC versus 5G and cellular. You will see from this presentation, we are firmly in the camp of DSRC right now because it's ready and live, and we don't want to wait 5 years to deploy this initiative. Let's go to the next slide. Therefore, to summarize, for those of you who haven't been part of all of our sessions for the last several years, the National Smart Vehicle Project vision and mission that CUTRIC has been designing and working to push forward with our members alongside us is one in which there's a joint procurement of integrated and interoperable electrified low-speed autonomous shuttles. We call these ELSAs because when you use the acronym CAV, Connected Automated Vehicle, often that refers in people's imagination and in news reports to automated and connected vehicles that are passenger car oriented. So we're trying to use the acronym ELSA to really focus on those low speed autonomous shuttles. So the vision here is a joint procurement of integrated and interoperable electrified low speed autonomous shuttles across multiple Canadian cities to achieve first kilometer, last kilometer solutions for transit agencies and airport authorities with common V2V, V2I, and cybersecurity protocols. You may wonder why we've added airports. It's because over the course of the last year, as we were struggling to find transit agencies ready to go to a larger fleet deployment in an integration trial, we had airports coming forward from Vancouver to Winnipeg to Montreal saying that they are interested in people mover shuttles, that they would deploy these kinds of technologies on their pathways and roadways to move employees from parking spots to the main airport terminal. And so we have brought in some of our airport authorities, some of whom have joined CUTRIC as fee-paying members in order to be part of this project. Same technology, same type of deployment, but in this environment, it's a shared fleet shuttle for employees at airports or potentially passengers at airports in dedicated laneways. And therefore, if you look at our vision and our mission statement's pretty clear in terms of what we want to do and disrupt within the Canadian transit landscape technologically. From a mission standpoint, we have particular assumptions underlying this. We are assuming that there are common or interoperable RSUs and OBUs at play. We are assuming the integration usage of DSRC. We are not waiting for 5G to be ready to move forward with this project. We'll be waiting half a decade. And we are assuming dedicated or semi-dedicated laneways, so SAE level 4. Is this perfect? Does it solve all smart vehicle needs? Will it be the panacea that solves all transit problems? No. Is it a great project that's going to advance Canadian landscape for transit technology and move more people over greater distances with less energy? Yes. And will it create jobs in Canada? Absolutely. In a hot topic industry at a time when, recognizing our surroundings, we really need innovative job growth to move this economy forward. Go to the next slide. So to take you through a couple of the high-level specs that we're going to be focusing on through the rest of the presentation, we are now looking at getting to approximately 30 shuttles, 30 ELSAs, distributed across at least 4 cities. If we have 2 or 3 cities partner, like we did in our electric bus project, we had 3 cities partner, that's good. 4 cities is very strong though. It would allow us to have a multiplicity of provinces involved, a multiplicity of provincial transport ministries involved for regulatory purposes, a multiplicity of cities from large to mid-size in Canada for passenger and rider experiential data, and a multiplicity of topographies and weather conditions to test out. So we really feel getting to the 4 mark is core, and probably 5 would be ideal, because if we want to get to a fleet nationally of 30 of these shuttles roughly being deployed, you can imagine that it would be hard for each city to go to a 10 shuttle deployment on day 1. So we're really looking at something like 4 to 6 shuttles per agency, per city in phase 1 of a common procurement to get us to roughly 26 to 30 ELSAs. We're looking for them to be standardized, and we're going to talk more about what that means, but specifically, again, the V2V, V2I communications protocols, standardized cybersecurity protocols, centralized operating systems for multiple manufacturers, so transit agencies are not dealing with a portal that reads to get their shuttle performance and Navia and Easy Mile. We're looking for a centralized, some meta level operating system that makes it it easy for transit or an outsourced operator to manage a multiplicity of makes and models in a particular route deployment. And we're looking for interoperability of charging infrastructure, which is extremely difficult in these shuttles. We spent about 2 years dealing with this issue at CUTRIC last year, and all the way back to 2018 and the start of 2017, it was clear and still is that charging systems are not interoperable, not standardized across these shuttles right now. Those are the goals. We may not get to all of these technical specs in our phase 1 deployment, but the first 3 are critical. The interoperability of charging is an open question right now that we hope to hone in and finalize by August of this year. We also expect that there will be, like our eBus experience, real-time data sharing and performance evaluation by a neutral nonprofit, ideally CUTRIC, in order to performance monitor these shuttles as they are deployed, so transit and cities know that what they paid for and what they thought they get is actually what they got. And so manufacturers know when there are challenges that they need to address in manufacturability, integration, or system performance. Go to the next slide. From all of that and building off our electric bus project experience, we are right now working with the federal government to move forward on an automated, connected, electric, and shared big data trust. And we know that this is where mobility is going, whether it's electric buses or hydrogen fuel cell buses or charging systems that are connected to an Internet of Things of smart infrastructure across this country, or autonomous shuttles. We know that we need to build out a data trust that is led by cities in transit, where all of this data is fed in real time and performance of units across cities can be monitored and observed by cities across jurisdictions in a seamless manner. And so that leads to the next slide. This project, along with our electric bus and fuel cell bus project, is leading to our national data trust. Just ask you, Lana, if you can go to the next slide. So there, our National Big Data Trust is a central repository of data coming off the shuttles, from the charging systems, from the OEM platforms, as well as the V2V, V2I communications, and the roadside and onboard units. The idea here, again, is to empower cities and transit agencies to really look at the performance of these systems in real time, develop performance-based metrics for long life cycle maintenance and operation. And that allows for the build out of possibly even really effective public-private partnerships where you would have the real-time performance data monitoring the private sector players who ideally would be profiting off the deployment of a system, but a system that is efficient and low cost so riders get better services and mobility at lower cost than they're getting them today. And you'd have the data through this trust to be able to performance monitor all aspects of that system to improve the product, the integration, the service to the rider, and also to improve evidence-based procurements going forward. Go to the next slide. So that brings you to a summary of what we have achieved so far in terms of our philosophical focus. Several of the companies that you see in front of you are some of the core industry stakeholders at CUTRIC. They are members of our consortium that have helped us to define this process. There are dozens of transit agencies that have been part of this as well, and several cities that have been part of this initiative over the last 24 to 36 months. And if we go to the next slide, we'll see some of the cities that were actively involved in our ACATS modeling. Go forward, one slide. There are some of the cities that were involved in our ACATS modeling, which we will talk about momentarily, as well as cities that have been involved in our effort over the last 24 and 36 months from a transit perspective to really define what are the technical parameters that would make sense for transit agencies. Because I can tell you and underscore again and again and again, as we have in the last 24 to 36 months, we're not interested in advancing autonomous and connected vehicle systems for passenger cars that add to congestion and simply add luxury to middle-class lives. What we're really looking for are shuttles that move people in a safe, secure fashion in a public fleet deployment environment that reduces emissions, improves mobility, gets people to their jobs faster, and improves our quality of life. That is our focus, and these cities have come forward at different points in the process over the last 3 years to help us define or test or model or simulate or learn lessons from their empirical deployments. Go forward to the next slide. For that, we're going to see if there are any questions quickly about what was just reviewed, because it's a very quick high-level overview. We're going to get into more details as we go forward, but we wanted to set the scene knowing that a lot of you have not been part of all of the technical sessions that have happened over those last 36 months. And seeing no questions, we're going to move to the next part of the agenda. And the next part of the agenda will take us through some more of the details of the technical specification. So first off, what I'm going to do is turn to my colleague, Elnaz Abotalebi, and we'll go to the next slide.
Yes, thanks, Yosefa. Hi, everyone. So in this part of presentation, I'll give you an overview of previous smart vehicle sessions that CUTRIC hosted in the past 2 years and the main outcomes that came out of these sessions, and specifically those outcomes that apply to smart shuttle joint procurement that CUTRIC is leading. So in terms of session 1, it actually was hosted in Toronto in September 2018. During this session, we had a presentation from our first shuttle manufacturer together. We got an overview of their systems in terms of physical vehicle platform, including their automated charging system, as well as their digital system, fleet management software, communication system, etc. So the main outcome and takeaway from this presentation was that Smart Shuttle used conductive low power charging system. And basically, this was a question about the snow during that session. The snow would not be an obstruction to this charging system, as it was reviewed since there is embedded heater in the charging system, and the charging plate is actually installed on the pavement, on the ground level, so snow can be plowed away and not to obstruct the charging process. Moving on to session 2, next slide, please. Yeah, so this session took place actually again in Toronto in October 2018. We had an overview of current global and Canadian standards for connected automated vehicles, on communication technology and cybersecurity. We had presentations from Siemens and Together, and the main outcomes was that, as Yosefa mentioned, that DSRC is going to be utilized for this project. This is established technology and it's standardized. So this is technologically and commercially available to be used for the near future. We also learned about two certification system, Omni-Air Consortium. This is actually a nonprofit group based in US, and they actually provide they run tests on devices to make sure that devices or vehicles are interoperable and are safe to be used. And there is another layer of security and certification, which is called Security Credentials Management System Certification. This add another layer of security, and this is also based in US and is initiated by US Department of Transportation. And what they do, they actually make sure that a device is not a malicious device. Next slide, please. In session 3, this session actually was hosted in Montreal at the end of 2018. We got a presentation from eCamion, ABB, and Together, and they presented interoperability of their automated electric charging systems, about their eCamion. We learned about their pantograph and a robotic arm charging system, as well as pantograph system that ABB produced. And we also learned about details of road grade plate system that Together shuttles have. And also we had a first review of ACATS modeling methodology at that time. The main outcomes from this session was that same pantograph charging system for e-buses can actually potentially be used for some shuttles as well, from the presentation that we had during this session. And a charging system can be throttled down to power levels that a specific vehicle battery can take. For example, if a charging system provides up to 450 kilowatt, but if a shuttle can only take up to 100 kilowatt, that's the charging level that will be provided by that charging system. Next slide, please. So moving on to session number 4, this was hosted in Ottawa in January 2019. We got an overview from municipal, provincial, and federal levels about certain parameters affecting automated and connected vehicles. We got an overview of City of Surrey and City of Brampton smart cities objectives. We also got an overview of Ontario's OREG 306/15. which is a regulation for automated vehicle pilot program. This was actually initially started in 2016, but was slightly modified in 2019 to make the regulation more applicable to connected and automated vehicle to operate in Ontario roads. From federal levels, we heard from Transport Canada about their self-certification, safety regime, and activities to support the safety of emerging technologies, as well as from ACATS, which will learn about their frameworks for data privacy. Next slide, please. Session 5 took place in Toronto in March 2019. We got an overview from 3 ELSA manufacturers, 3 main manufacturers, Together, EasyMile, and Navia, from a detailed overview of their system. And the main takeaway from that was that ELSA fleet management data could be integrated into one central operating system, given that their IP can be protected. We also got a review of automated electric charging systems from LX wireless automated electric charging option and eCamion plug-in automated charging system. We also heard from SmartCone Technologies about their data collection and signage infrastructure. So SmartCone is a company that places physical cone along the roadway, and these can actually collect data from vehicles and infrastructure and store it where it needs to be stored. And we learned from this presentation that this smart infrastructure can actually operate with multiple OEMs as well. Next slide, please. Session 6 took place in May 2019. This session was actually a cities only session. So whatever information that we gathered during the previous session, we actually presented them to cities. We just want to give cities the opportunity that could get all those information and ask their questions. So we had an overview of OEM systems in terms of shuttle manufacturers, their automated electric charging system. And we also heard from a city deployment timeline for electric shuttle deployment at the time. And the outcome was that there are some visions to develop the idea of a smart cities, but there was not a defined plan at the time for Canada or actual shuttle deployment. So next slide, please. In session 7 in July 2019, actually in this session, what we heard from cities in the previous session, excuse me, we just want to present them back to OEMs. So we heard from City of Vancouver, Surrey, Cochrane, Winnipeg, both city and airport authority, Brampton, TTC, and Montreal. And just want to share their points with manufacturers and OEM at this session. We also went through funding options at the time, Strategic Innovation Fund, Stream 5, Western Economic Diversification Canada. These were the available funding at that time. And we also reviewed, we had first review of Innovation P3 initiative. And the main outcome from this session was that actually a joint procurement is needed potentially with an asset and operations, leasing, or co-financing mechanism, since it is very difficult for a single transit agency to be able to operate on its own. Next slide, please. And session 8 was the last session in 2019. It took place at the end of 2019. And we got an overview of CUTRIC ACATS project that was funded by Transport Canada. At the time, it was close to completion, so we reviewed in that session. We also got we started the dialogue with Innovation P3 initiative option, with details of this option from CUTRIC's, which was evolved from CUTRIC's Pan-Canadian Electric Bus project, and extended it to a smart vehicle project. And we got we gave an overview of CUTRIC National Academic Committee, or NAC. So this is actually a cluster of academic researchers from different universities across Canada. And these researchers actually work on different aspects of smart vehicles. And for example, from vehicle performance, snow impediment, cybersecurity. And what we do, we actually get the project updates and deliverables from these researchers and academic, and presented it to our members and industry stakeholders going forward. And we're gonna provide some presentation from these academics in our upcoming sessions. And actually the main outcome from this whole session was that to move beyond one-off pilot and into sustainable transit-led procurement, CUTRIC needs to define and lead a national joint procurement initiative and help a group of cities, transit agencies, or airport authorities to define appropriate technical specification to ensure interoperability and future procurement resilience. Next slide, please. Yeah, so related to that, we had CUTRIC first announcement of our National Academic Committee Smart Vehicles, which took place in Windsor last month, and we actually announced a total, and sorry for this slide that is not correctly presenting, but we announced a total of $1.2 million that is funding researchers from half a dozen universities across Canada, which is coming from CUTRIC and its members that contributing to this funding, as well as federal funds. And as I mentioned, these researchers we will provide updates on their deliverables, and is providing useful information for this joint procurement moving forward. Next slide, please. So in summary, just to summarize the outcome from CUTRIC previous technical sessions, these are a summary of outcomes since the focus of this project is on standardization. So we just want to make sure we have a standardized charging system, communication system, V2V, V2I, and cybersecurity design protocol. So this is possible, but it needs to be properly planned, agreed by OEMs, integrated into cost of the joint procurement, and regulated. In terms of smart shuttles, actually in terms of charging of smart shuttles, some smart shuttles can be designed to be charged with on-route chargers already installed for e-buses, and this is the case for some transit agencies, Brampton, York Region Translink, STM, that already have planned or already installed these en-route chargers. In terms of a fleet management data system, smart shuttle fleet management system could be integrated into existing transit central operating system and merge into one meta-level platform, so transit agencies don't need to have like a separate system for those shuttles. Next slide. Also, in continuation of the summary of outcome, dedicated DSRC, which is dedicated short-range communication systems, established system and commercially available, so will be used for this joint procurement. And the shuttles that we plan for this procurement are the shuttles that actually are allocated to dedicated laneways. So we use dedicated or semi-dedicated laneways, since these shuttles are at level 4 of automation. And other aspect of smart shuttles for operations in terms of digital and physical infrastructure, maintenance, software updating, and performance and data analysis component of this shuttle can be actually outsourced as part of a leasing-oriented or innovation P3 joint procurement to the companies that are expert in these areas. Next slide, please. Also, in parallel of these sessions, CUTRIC was also conducting ACATS projects. So I just go through the summary of outcomes from ACATS project that will be utilized for this smart shuttle joint procurement. First and most important is that route-specific predictive modeling is actually needed before actual deployment of the shuttles. In terms of the route that the shuttle is going to operate, high gradient slopes actually consume significantly more energy. And this came out of the results of our modeling during a ACATS study. High power opportunity charging is required for heavy duty routes. In terms of lane, as I mentioned in the previous slide, dedicated or semi-dedicated laneways are appropriate for the operation of these shuttles. And the CUTRIC preliminary assumption is actually 10% ridership increase in local transit once smart shuttles in operation for first kilometer, last kilometer solution. And in terms of data, we actually need more empirical data from pilots to validate these outcomes. So these are just the main summary of outcomes from ACATS project. If you can move to the next slide, please, Lana. In terms of what's next for CUTRIC's 2020 strategy for the smart vehicle project, so we actually will gather feedback about technical specification and project vision after today's session, and I will ask you later, so feel free to email me with any feedback or question or comments that you have about this project, and we will identify final coalition of the willing joint procurement MOU with our partners, both transit and cities and airport partners by the end of June. ACATS with ACATS pilot cities and other pilot jurisdictions. So these are the hot leads, such as Durham region and Oshawa. And this we will provide basis for memorandum of understanding by the end of August. And we will design a full life cycle funding and financing proto model to support MOU advancement by the end of July. And we will complete a full route, full service feasibility analysis in terms of energy consumption, ridership level, and transit scheduling, that we will present to you some details of our ACATS modeling later on today. And so we will complete this by the end of October this year. And we will submit to Government of Canada the results of our funding option to Ministry of Transportation and Infrastructure and Canadian Infrastructure Bank by the end of December 2020. So with that, I just want to turn it over to Josipa. Josipa, if you want to add more points to this.
No, I think you captured it well. There is a revision to item number 3 in terms of our plan has always been by December 31st that we get in the full funding bid and the full financing bid. It is being expedited a bit just because COVID-19 and the economic situation, ironically, has created the opportunity to move forward much more rapidly with economic development initiatives. This is an economic development initiative. There's no doubt about that. It's also a transit and transportation initiative that reduces emissions and helps the government achieve its long-term mandate. So I'll be speaking to that in a moment. We have several questions on the line, Elnaz. So I believe that that is your last slide. We'll just go to the next slide for Q&A, and I'm gonna work through everybody's questions here one by one. And I note that several of you registered for the webinar with your personal emails rather than your corporate email, and I understand why, for the obvious reason that several of you are blocked from using Zoom during this time period. So apologies if right off the top, I do not remember exactly which company you're associated with. I think I've got about 90% of you in my brain, but not all of you. So I'll just take you through the questions that have been asked so far. First off, in terms of some of the questions, one from Jeremy Spira. Jeremy has asked whether there are any OEMs that have shown interest, both potentially on the charging side or moving away from internal combustion engines and wanting to future-proof, to possibly also on the integration side, et cetera, and on the standardization side. So the answer to that question is yes. There's a series of manufacturers that have shown interest to the point of being members in good standing at CUTRIC, and they have helped to hold our hands. So number one for sure is To Get There, and our colleagues from To Get There are on the line today, Robert Lohman and others all the way from Europe and the Netherlands. They have been designing and building and manufacturing smart shuttles for 20 years now. Their insight has helped us to divide out pilots from integration efforts and to design more robust deployment technical specifications based on their multiple years and multiple phases and generations of deployments. So there's definitely interest from that manufacturer keen to deploy technologies that move this needle. Then we have Navia, that has been a partner of ours for some time now, over 2 years, and they have helped us to come to understand what their technology is capable of doing, the pilot projects that they have launched, and their goal of integrating more robustly with transit operations as a shared fleet provider. as well as a service provider. In the past, one of our members was Easy Mile. They're not currently a member of CUTRIC, but we hope that they will come back into the consortium. They have also provided very good knowledge to us about the technical specifications of the vehicles themselves, as well as their operations. So that's on the shuttle side. On the other manufacturer side, we have bus manufacturers, as noted, New Flyer colleagues who are on the line today, as well as Nova Bus colleagues who are on the line today, both of them interested for over 3 years in this project when it was just a seed of an idea in 2017, largely because of the transfer of the technology in terms of vehicle to vehicle and vehicle to X infrastructure to ADAS supported buses or partially or fully automated buses. And one of our long-term goals at CUTRIC from our Pan-Canadian Electric Bus Project, as well as our National Smart Vehicle Project, is to automate electrified buses on rapid transit ways, so that on rapid transit ways or on the portion of the rapid transit way that is dedicated laneway and non-mixed traffic, you could have optimized drive speeds, optimized distances between buses. You basically get a lot more movement and capacity for human beings and passengers in a lot shorter intervals, because what you would have, ideally, if we could get there, is pretty much a rail system on rubber wheels without the rail track. If you could get to that level of safety, security, automation, and precision, that is one of the long-term goals. And before getting there, there's all sorts of lower level automated technology tools that are needed. For example, we want to help our bus manufacturers get the automated technology on board, say the Nova buses or the New Flyers, and partially Proterra already has this, another member of ours, where the charging system and the bus communicate in real time, and the charging system and the bus communicate such that the driver doesn't really need to position the bus into position to charge with an overhead pantograph. Rather, you have an automated process where the bus optimally pulls in, the pantograph releases, maximum number of seconds are deployed for charging at high power levels while passengers are getting on. The pantograph automatically retracts, and the bus automatically emerges from its charging location. Portion of that, a large portion of that, could be automated to take out driver error, or just to take out the time it takes drivers to be able to do that efficiently, or reduce the training time required to do that efficiently. It's a very difficult process at times, and it takes training to be able to do it effectively and efficiently, and automation can help. And also automation can help for safety, ensure that the bus is not moving forward or the charging unit's not deploying when maybe people are around in an unsafe environment through object detection. So there's all sorts of applications that would come out of this project. You learn a lot when you do a large integration trial. You learn a lot about the things that don't work at the integration level and the things that need to be improved for a full fleet deployment. And a lot of that is transferable to our bus landscape. Whether it's transferable to coach landscape is an open question. We're just starting the coach electrification dialogue at CUTRIC, and coach automation is a ways off. But we do also have manufacturers on the rail side. So our colleagues at Bombardier Transportation, which has been one of our members since, well, I'd like to say time immemorial, but we're only 5 years old. So they've been a member of ours and on our board of directors for several years. And they've been consistently participating here in terms of transferring automated technologies from the rail sector to the shuttle sector and vice versa. Similarly, our industry partner Thales, Thales Group, which does do automated train controls for subways and trains across the world, including in Canada, out in Vancouver with the SkyTrain. They have been a partner here in terms of the transference of their automated vehicle systems to smart shuttles that are essentially little rail cars without rail. So there's a lot of transference of knowledge, and a lot of our OEMs from heavy duty to the shuttle, light, medium, light duty landscape that are keen on this. There are then our manufacturers on the charging side, and to give you just a quick survey, Siemens, ABB, eCamion, these are some of the charging systems and energy storage companies that are keen on making sure that there are charging solutions here, as well as our colleagues at Elix Wireless, which is a great technology provider, and they're advancing wireless charging. These are all our members at CUTRIC that have identified an interest in this project moving forward for their own technology deployment or for the transference of knowledge for their own technology design. So hopefully that gave you a robust answer, but the answer is yes to your question. Several other questions. We're going to take a couple minutes here because we finished a little bit quick on the items that we're reviewing. We do have a question also in the chat panel, and John, I'm going to go to you. So we have our colleague John Ulakovic at St. Clair College, who has asked whether we have any discussion with Windsor and Detroit to offer this service for cross-border commuters. Because in, of course, Windsor and Detroit, there's a large number of daily commuters who travel a short distance across the border, as John's pointed out. The answer to that is an emphatic yes. In fact, we're working with Windsor Transit, the City of Windsor right now, on the electrification of their fleet. But we have over 2 years discussed the idea of automated electrified shuttles that are moving across the Windsor-Detroit border. And this would be one of the first in the world, we believe, of a cross-border integration effort of these technologies, both for electrification, but especially for automated shuttle deployment cross-border. It's a great opportunity. And in fact, just over a month ago, I was in Windsor, again, discussing these possibilities, whether they're automated bus shuttles or automated smaller shuttles of the type we've been talking about here today. There's a lot of interest, as you've noted, in Windsor. There's interest at CUTRIC, and I believe that there would be keen and core interest at the federal government level, because what a deployment in the heart of the automotive country on both sides of the border, that we could deploy automated, electrified, optimized people mover shuttles across a border that has become increasingly congested. So the answer is yes, we have more work to do, and we certainly are keen to have Windsor Transit, the city, and Detroit part of this initiative going forward, because of the branch of government it brings into play from a foreign affairs perspective and foreign technology development and integration. Then we're going to and we have several other questions. I'm going to field one right now and then come back to a few others as we go along, because we want to keep on track, and we do have several additional pause points for queries. But we have one question from Lauren. And Lauren Isaac at Easy Mile has asked whether funding's been identified for this procurement. So the answer to that question is it's been identified, it hasn't been won. And so we are hot on the trail of attempting to win it. Over the last few years, we have really focused on a funding solution, because when you're in technology integration trialing, there's a lot of risk, and we're asking our transit agencies to absorb a lot of risk. And we learned a lot of lessons through our electric bus project. So you kind of have to ask transit agencies to take on that risk by giving them the funding to actually deploy this appropriately. Given, if I were to talk about pre-COVID and post-COVID, pre-COVID, heading into the end of 2019, it was pretty clear that there was a limit on what the Canadian taxpayer could do. I mean, that's obvious to all of us. So for our electric bus deployments and our fuel cell bus deployment that we're working on right now, funding was core, but we were moving really robustly last year into a P3 dialogue, and we're going to discuss that a little bit more coming up, because it's clear that the Canadian taxpayer is just not rich enough to fund all of these things on day one from a capital operations and maintenance perspective, not to mention the data analytics, real-time assessment, and the life cycle operations over the course of these vehicles with an unknown life cycle attached to them. So that's where we were 2019, and we're still in the zone. I'm certainly still in the zone of believing we do have to find innovative financing tools, whether that's simple leasing programs, operations and maintenance outsourcing, or they're a combination of public funding plus operations and maintenance outsourcing with some leasing component and equity buy-in. Innovative financing tools are going to be critical to transit. There's no doubt about that. But that was also pre-COVID, and our priority has shifted slightly because of COVID and the economic disaster that we're all facing right now. It is also very clear, to their very great credit, that the federal government and other levels of government are working very hard to stimulate economic development. And so since we are in a period right now where economic stimulus is going to be a core focus of discussion at all levels of government, starting in the next week to 2 weeks, as we get over the immediate hump of making enough masks and ventilators to take care of our fellow country people, we want to start turning towards the idea of how do we create jobs in this green, clean sector, and how do we deploy more transit, not less transit, post-COVID. So we have turned our attention at CUTRIC to looking at the economic development opportunities. In the last 2 weeks, we have submitted a series of stimulus bids at the federal and provincial levels, asking for support for electric bus simulation and modeling, the Big Data Trust, ZEB rollout planning for e-bus and fuel cell bus systems and energy systems and fueling systems, all the things that we've had in the pipeline for several years that we were looking to complicated P3s to deliver on. We are starting to ask for that support on day one from a funding perspective, knowing that money needs to go out the door to create jobs, and public works is part of that, and transit is part of that. This smart vehicle project falls in that zone. It's not as expensive as electric buses and fuel cell buses in theory, although time will tell over the next few weeks as we start to budget it out in precise numbers. But it's more complicated. Frankly, from a digital communication standpoint, it's more complicated, more moving parts. So we are at CUTRIC now going to be working with our members in the next 2 months to put together an economic stimulus bid to the federal and provincial governments, identifying what a 4 to 6 city play with about 30 shuttles across the country would look like from a cost perspective if the funding were available in a post-COVID world. We may find out that the money is used up, that there's a limit to how much debt government can take and how much they'll deploy, but this project certainly falls in the right zone of economic development, technology innovation, job creation, and green transit. And so to your question, Lauren, we have 2 possible funding mechanisms we're going after. The P3 arrangement with a financing option, but in the immediate short term, it is most certainly a funding bid to government to get it through the pipeline of economic stimulus over the next couple months. So with that, I'm going to pause on the questions for the moment. We're going to come back to more questions. Please keep posting them. We do have more pause points, but we want to keep on track. And with that, we're going to go to the next slide. And I'm going to introduce my colleague, Mahmoud Nasheli. Mahmoud, will turn it over to you to take us through this portion of the research that is also feeding into our MOU, technical planning, and joint procurement efforts.
Thank you, Yusipa. Hello, everyone. Today, I'm going to present 2 presentations which are related and are in line with the Smart Vehicle project here at CUTRIC. So at the first one, I will talk about the summary of the stakeholders' interview outcomes about the deployment of these smart shuttles. And for the second one, we will see what is the user's perceptions about the smart shuttles, the outcome that we did some analysis based on the Twitter data analysis. Next slide, please. So for the first presentation, which is about the experts' view about this deployment of autonomous shuttles, the objective is we want to gather the feedback from transit agencies, industrial stakeholders, and government entities regarding the opportunities, challenges, and solutions allied to the automated transit technology deployment. And also, the outcome of this research will help CUTRIC to better formulate its national smart vehicle project. Next slide, please. So as you know, the Smart Shuttle the project has many stakeholders, and many of you in these webinars are stakeholders. So far, we interviewed with 14 stakeholders, and our target is to conduct 40 interviews in total by end of June or July 2020. And our stakeholders are there from different organizations. We have from manufacturers, cities, government, consulting, transit agencies, operators, and also from academic as well. Next slide, please. This is the list of stakeholders that we conducted interview and we completed, and we plan to continue with other organizations in coming months. Next slide, please. So the method that we are using for this interview is actually focusing with a kind of semi-structured methodological framework. And it means the interview is a kind of interactive interview based on the, besides of some fixed questions, we might have asked some follow-up questions depending on the conversation direction to get much more deep understanding about our experts' views. So the interview transcript is specifically designed to explore about 3 main themes: opportunities, challenges, and solutions associated with these smart shuttles. In total, we have 12 fixed questions that deeply investigate the viewpoints and experience of stakeholders from different perspectives, from economic, commercial, technological, innovation, social, cultural, political, and environmental perspective. Next slide, please. So based on the main themes, we did a kind of thematic interview, and this is the outcome of this thematic interview. So the first things that we wanted to investigate was the opportunities, and we asked different questions about to highlight what are the main opportunities that this deployment of a smart shuttle can bring to us. In terms of economic, mainly related to the long run, our stakeholders are telling us that public transit could be available at a lower cost for both people and operator. Many cases are small, therefore a small shuttle is profitable instead of running some fixed route or bigger vehicles. In terms of the technology evolution and widely available can create a kind of opportunity to have a better software and hardware improvement. This advanced analytical and AI can create a kind of system that the system in total could be efficient. One of the main features of this a smart shuttle is connectivity. So when we have a kind of this connectivity, there would be a kind of better communication with infrastructure as well. Next slide, please. So for the operational part, the main thing that we all know is about the first kilometer and last kilometer solution that can very well help us to feed our existing transit systems. And also that can serve lower density markets, which is operate in a wider area, geographical area. That can also bring the new mobility service that we hope that can improve the ridership and reliability. In terms of the social, that can bring the benefit to more passengers. For example, those passengers, they have kind of less able-bodied people and they cannot travel with this fixed system. It can improve safety to both users and residents. It can increase accessibility because we are proposing much more transit solution. It can building some kind of community because due to promoting public transit, we will have less parking area that can help us to better land use as well. Next slide, please. So in terms of the political, the opportunity could be to promote public transit. Therefore, we are reducing the number of private cars. It can help us to better spatial planning and improve the mobility with the same degree of using the mobility for the better land use. It can propose the advanced technology for the transit system, especially because many of these new technologies so far is for the private car systems, but we can bring all of this technology to the transit system and have a kind of better transit and higher quality. In terms of the environment, because they are electrical and therefore we are reducing the carbon footprint reduction that can improve the air quality. It can reduce the congestion because we are promoting the transit system. Therefore, we will have a kind of cleaner city environment. Next slide, please. So besides of those opportunities, we will have some challenges. So we ask about what kind of challenge that you are seeing out of this deployment. The main challenge about the economic was the much more upfront cost, both for procuring and operating. And you know, the generally transit agencies, they are suffering from funding. So the lack of funding for transit is a challenge because they want to spend public money. And in terms of the finance in the business case, especially our manufacturer, they're saying that should be viable in the long run. And finding availability is another challenge, and because sometimes there is a competition for the government funding in general for other projects as well. For the technology, intelligent interpretation, there is a kind of question about understanding. Sometimes there is a seeing false positive. For the power, processing of the power, there is a kind of question, can all the object and environment be correctly monitored and processed in a timely manner? And in terms of the different circumstances and exceptional cases, for example, in a severe weather in Canada, can technology help us and can technology deploy and operate properly? And there is a question about the sensory system, are those safely certifiable, and other sort of question about the technology itself. Next slide, please. For the operational, the main concern for the manufacturer is interoperability. And for the speed of this vehicle, less than 25 kilometers usually. So because of that, there is a kind of limitation to some specific routes. Technology readiness level is a question in terms of the safety operator should be on board. There's a challenge in mixed traffic. So all of this question is happening when we want to go to the operational level. For the social, people feel kind of concerned in general about the safety, security, privacy, and technology itself. Public acceptability about, because people, they're thinking they want to go for the shared vehicle and a smaller vehicle. There is a concern on that part as well. Because of some lack of first-hand experience, shuttles, people thinking that kind of shuttle can do everything. So there is a kind of question and challenge in this part as well. Next slide, please. So for the planning, the main concern is about the regulation, and the stakeholders are saying regulation are not ready yet. Example could be a compatibility of issue for the various charging system, certification and regulation approval for the technology itself, for example, for the AI and big data. There is a question for that. And designing the infrastructure, it should be either dedicated lane or mixed traffic. For the liability, responsibility for if something is going wrong, what could be the answer for these kind of challenge and questions? Next slide, please. So out of all those challenges, we ask our stakeholders, what are the potential solutions? And for each category, we highlighted some high-level solution out of that. For the economic stakeholders are suggesting public-private partnership, P3 model could be one of the solutions. Leasing of vehicles could be one of the solutions. Dedicated funding source for transit in general, that could be another type of the solution. Because these vehicles are a part of the electric vehicle green transit system, therefore government can provide funding from the gas tax money payer. In terms of the technology, our stakeholders are suggesting dedicated or semi-dedicated lanes should be focused, and the infrastructure adaptation should be completed properly, and we need to standardize our technology and safety and make those as a priority. Next slide, please. For the social, there is a kind of common agreement about increasing the public knowledge in total and educate people, manage expectations. People need to have a kind of actual first-hand experience to feel that and understand what is this technology. And also there is another concern about the transit driver, and there is a kind of, there should be negotiation with transit driver unions because some of them should lose their job because of these automations. For the policies, our stakeholders are saying that cities and government need to define the strategic goals in their AV policies. They should prioritize public transit solutions and deprioritizing car and less parking. And moving people should be priority, not focusing on the technology or of the mixed traffic at this stage. And establishing the legal framework is important for the regulation and standardization. And also business case should be solid, so in terms of the commercially viable and socially acceptable. Next slide, please. So if we want to highlight the opportunities and challenges on a high level, for the opportunities, we will have, this technology can bring us affordability, it can improve mobility, it can increase accessibility, democratize public transit, and due to advancement of data analytics, we can have a kind of much more efficient system. The system is green because we are using electric for these kind of smart shuttles. Therefore, we will have a clean air quality and better community. And main challenges we are facing is regulation, certification, standardization, and liability, and interoperability in general for all of this aspect in terms of technology and also in terms of deployment and operating. The funding availability is another concern. Solid business case should be defined. And there is a question about technology capacity and capability at this stage. And also we should address public acceptance and experience and concern about this. For the solutions, we should prioritize public transit policies. P3 model could be a kind of effective approach. And we should establish a legal framework for regulation and standardization and increase public knowledge, and also start to negotiate with the transit driver unions. Next slide, please. So the key finding out of all this preliminary analysis, there is an essential need for a coordinated and a structured dialogue engaging core stakeholders from government, from political, from the potential user, transit riders, and also private industry to generate an immediate ELSA roadmap, preferably in 2020 in Canada. So the roadmap must include a strategic plan with a timeline. That strategic goal or plan could be a kind of reduction of the congestion and also car reduction in the service area. What is the percentage of the transit ridership increase in this area and so forth. Next slide, please. And also the roadmap must list and clarify the performance and operational rules and regulation that must be developed and put into place to enable the effective, efficient, safe, and cyber-secure deployment of these smart shuttles on Canadian street. And we are emphasizing here as a dedicated and semi-dedicated laneway in 2020 and 2021. The roadmap must include the monitoring of performance indicators related to the administration of rules and regulations. Next slide, please. Therefore, the general vision statement of this national smart vehicle project based on a joint procurement with a P3 model would be to bring together 5 to 8 cities across Canada to deploy these ELSAs over a 3 to 5 year period to reduce congestion and increase transit ridership in a given service area. As I mentioned before, the targets are reduce car congestion or parking in a service area by 5% and also increase transit ridership in a service area by 5%. The next slide, I think this is the last one. Thank you very much. If any questions.
Thank you so much, Mahmoud. And we have a lot of questions that have popped up, in part stemming from the first part of the presentation, then popping up as a result of your presentation. I'm going to turn to a series of those questions and work through them before we go to the next part of the additional detailed feedback and research that we were able to complete with Mahmoud being able to obtain user sentiments.
Sure.
So I'm going to move through the questions. First off, from our colleague Anne-Marie Carroll at York Region Transit, a question that we've got before several times, and that does require elaboration and clarification. So on the autonomous vehicle side, not the connectivity, but the autonomous features, what's really the benefit of CUTRIC trialing level 4 when level 5 solutions are needed? And the answer, and I'm going to get into a little bit of detail here, is level 5 is not needed nor ideal for transit applications, but level 4 requires a system redesign of the urban landscape in order to make it applicable. And the reason for that I'm going to get into, and why we don't want to wait for level 5, because we will be waiting quite a long time. And our goal is to move this project forward in the next 24 months, not the next 5 years or 10 years, for full deployment of automated technologies in all conditions, all traffic environments, no parameter set, which basically defines level 5. So let's just remind ourselves for everybody also, what is level 4, what is level 5? And let's keep in mind that these levels by the Society of Automotive Engineers were designed primarily with the automotive passenger car sector in mind. There has been a lot of dialogue about the applicability of these levels to shared shuttle fleets. And there is a large dialogue about refining the levels of automation for shared shuttle public fleet deployments. There has been some of that refinement, and for those of you who have been following the SAE J3016 standards, you'll know that in January of 2019, just a year ago, the SAE issued an updated graphic visualization of what comes under level 4 versus level 5, as well as all the other levels. So first, I'm going to go through what the updated guidance indicates, because it leads to the conclusion that has come out of our technical planning session that level 4 is where we want to be if we're focused on moving people through transit or shared mobility applications into the transit sector. So level 4 right now identifies, as does level 5, that you are not driving when these automated driving features are engaged, even if you're seated in a so-called driver's seat. From a single passenger car perspective, that makes sense. There's a driver's seat, but under level 4 and level 5, you're generally not driving. You're not driving. That's not your job. Now put it into a shuttle or a bus environment. It may mean that there's a driver in a driver's seat, but the driver's not driving. Put it into the shuttle perspective of the kinds of shuttles we're talking about here. There is no driver's seat. So the space is used for passengers, not for a driver. There may be a conductor seat for helping people on and off board, but there's no driver seat. So right away, we see how the SAE level 4, level 5, and all the level differentiations are really designed around thinking about cars. If we think about them as shuttles, there is no driver. So SAE level 4 assumes no driver, and that the driver is not driving, even if they're sitting in some kind of quasi-driver seat. That's the assumption. The second aspect of SAE level 4 is that the automated driving features do not require you to take over driving. So under SAE level 4 and level 5, there is no situation in which you take over driving when automated features are initiated. So already SAE level 4 is more than sufficient for the transit application. Now let's talk about some of the differentiating factors between level 4 and level 5. In a level 4 environment, the automated features can drive the vehicle under limited conditions and will not operate unless all those required conditions are met. Whereas in level 5, the vehicle can drive under any conditions. Whatever society throws at it, whatever our roadways look like, whatever our pedestrian crossing ways look like, the vehicle can do it. There is no reason for transit in Canada to wait for level 5, because if we want to move people efficiently in a low carbon way, we're going to have to redesign our streets. Just like it's not possible to put bicycles on highways and expect cyclists to be safe. That's not possible. That's why we create bicycle laneways. So level 4 assumes that we're going to impose some parameter conditions to make it safe for the shuttle to drive without a driver and without the driver having to intervene. And some of those parameter conditions that we are embedding in our project, which is why we're thinking of a P3, is slight rebuild of the streets. It may look like an expanded bicycle lane for smart shuttles. It may look like, if you live in Toronto, down on Queen's Quay, where you have dedicated laneway for streetcars, bicycles, pedestrians, and now very much reduced laneway for single passenger cars. That's what's going to be required. And so if we wait for SAE level 5, which may come one day, where those shuttles can be deployed anywhere without changing anything about the streetscape, that's an interesting project 5 years from now for CUTRIC. What's an interesting project for us right now is level 4, where we create the limited conditions under which these vehicles can operate without a driver, safely, securely, quickly, efficiently, and in a fashion that improves mobility. And the way to do that, those limited conditions, are dedicated laneway. Now, the reason we're saying semi-dedicated is because we might not need to put up barriers or create an automated shuttle laneway in all cases. There are cases in this country where there's already semi-dedicated laneway that could be easily dedicated or rendered limited enough to make it safe for these shuttles to operate in those parameter conditions. For example, downtown Toronto, and although I'm a Calgarian, for some reason Torontonian examples are coming to me, probably because I'm isolated right now in downtown Toronto, but we have the King streetcar. The King streetcar operates along King Street in Toronto. Cars are only allowed for a certain amount of distance now in this limited environment of King Street. It is entirely feasible for us to think about the mayor converting King Street into transit only. That's a dedicated laneway. And these shuttles could operate in between streetcars to add additional driverless capacity during peak periods, or to deliver driverless capacity during non-peak periods when there aren't enough driver-controlled streetcars on the streets, but there might be an event or a surge or an on-demand need. That deployment would be SAE level 4. And there's really no reason to wait for SAE level 5 to advance that deployment. We can also think of various examples where you could expand the bicycle lane effectively to create an automated shuttle deployment lane. These are low speed shuttles. They're not traveling at 60 or 70 kilometers. They could in some cases, but that's not what we're focused on in our phase 1 deployment of an integration effort. If we focus on those high speed deployments in all mixed traffic, we won't get this project out the door in Canada. And so we won't create the jobs and we won't be able to get to these procurements. That's why we're looking at level 4, because it's feasible, it's workable, and because it aligns with how transit operates right now: rapid transit ways, streetcar lanes, bicycle lanes, dedicated laneways for non-passenger cars. Important then is to go into the final outcome of the SAE level 4, level 5 differentiation from January 2019. Importantly, the Standards Association itself indicates that level 4 is ideal for local driverless taxis. So level 5 is ideal for a person who wants to drive everywhere in all conditions under any time. That's not what transit does right now. So why would we wait for SA level 5? Where we are right now is much more aligned with local driverless taxis. Although transit has fixed route, wants to move to some on-demand, local driverless taxis are shared mobility platforms where the standards body itself is recommending SA level 4 is the optimal solution. So for all of those reasons, looking at the readiness of level 5, the readiness of our urban infrastructure to absorb level 5, the empirical evidence from the pilot projects around the world that have come back showing the very serious difficulties in moving shuttles forward when all conditions prevail, from pedestrians to four-way crossings to various speed changes to various unexpected traffic and congestion. Shuttles have a struggle to deploy in those environments. That is generally the case with variability by make and manufacturer in terms of experience. Level 4, however, offers us the opportunity of coming halfway. The shuttle is delivering a lot of autonomous capacity that serves the need of moving people rapidly in a low carbon manner in a transit environment. But we have to come halfway as a city by also slightly redesigning our streets, or at least slightly identifying that they are going to be dedicated or semi-dedicated laneway, or leveraging dedicated laneway that already exists within our transit family, or could be made to exist reasonably easily. And to be honest, in a COVID world, post-COVID world, there's a great opportunity with all of the dialogue about people now not wanting to get back in their cars and get stuck on a highway and congested and waste their life behind the wheel of a car. It may well be that we now can turn this horrible thing called COVID-19 and the horrible outcomes that have prevailed into an opportunity for redesigning some of our streets to really get shared mobility out the door in a way that we couldn't have with all of the vested interests at play previous to this epidemic and pandemic scenario. So that is, hopefully, Anne-Marie, that explained why we're securely technologically in the domain of SA level 4. The standards body itself is not recommending SA level 5 for shared public fleet or shared platform devices. It is a nice to have if we can get there, but it's not a needed for transit applications today. So with that, I'm going to go to one more question before we turn back to stay on agenda. We have several questions and I will get to them. Lindsay, I'm going to get to yours after Hank's, and we'll see if we have enough time to answer both of yours before we move back to Mahmoud. One from Hank Wang at Brampton Transit. Hank has asked, among the various twists and turns that we've gone through over the last 8 sessions, and in fact, I would add, Hank, we've reviewed 8 sessions, but there's actually been almost 30 sessions since we started this in 2017. Were there attempts to explore with participants potential use cases? Yes, and I'm going to hold that question because when we get to the ACATS review section, we're going to review the modeling outcomes that emerge from the routes that transit agencies selected, including Brampton Transit. So there were use cases, there were applications that transit agencies selected, and with funding support from the federal government through their ACATS program run by Transport Canada, we simulated what shuttles in those use cases would look like. So I'm going to hold the answer to that question because we also have lessons learned from simulating some of those use cases, some of which are regular mixed traffic environments, some of which were much more specialized dedicated laneway environments. So we'll come back to that, Hank, and take a look at them and then answer your question more robustly after the ACATS presentation portion. The next question comes from Lindsay Wigington. And Lindsay, I hope I'm saying your name correctly. But the question is, could we feed off the ideas and learnings that the City of Toronto has developed? Because Lindsay comes from the City of Toronto. City of Toronto, TTC, Metrolinx have a number of lessons learned from their automated shuttle procurement program that they'd be happy to share. And my simple answer to that question is absolutely. Over the last 2 years, we were desperate at CUTRIC to find empirical evidence. And I can tell you from 2018 into 2019, there were lots of pilots, as you're well aware, from Las Vegas to Paris, to Surrey, to Calgary, et cetera, et cetera, et cetera. Some of those pilots collected data, and some of our colleagues on the line today from PW Transit, which operated the Ella shuttle in a lot of Canadian cases, had some data that they could access. The OEMs of those shuttles have some data. A lot of the transit agencies or the cities collected some data and produced outcome reports. So we were collecting those data. In particular, Calgary Transit and City of Calgary have shared with us all of their lessons learned. But I would say it is fair to say on all sides, there's a dearth of data that has been overarchingly shared in a transparent fashion. from shuttle to user to rider. And so one thing we can do a lot better going forward is make sure there's better, more transparent data collection on all sides of these deployments for lessons learned. So we will definitely be leveraging City of Toronto because last year we did work with some of your colleagues at the city and TTC to try and identify how much data, what data is going to be shared, what's the procurement spec, what are the problems you're facing with your procurement, and what are the deployment challenges. In sum, as we'll talk about at ACATS, the federal government funded a whole bunch of pilots across Canada, and there has not been enough coordination work as Canadians in terms of us all sharing those deployment data with each other to improve procurements. So with that, I'm going to turn back to Mahmoud. Doug, I'm going to get to your question, Doug Parker. Very similar question about transit agency use cases for first kilometer, last kilometer. We're going to answer your question with Hanks once we go through the ACATS results. So stay tuned for the answer to that. Back to you, Mahmoud, for the next portion of our presentation.
Thank you very much. So we already, thank you. So we already look at the expert's view in this presentation that we did a kind of research to understand what is user side and what is the user concern and perception about these smart shuttles. We did a kind of research and we did analysis for the Twitter data. The reason we did Twitter data analysis because, as you may know, this is one of the cost-effective way of evaluating the user's opinion in a global scale. So we wanted to understand in a global scale what people thinking about these smart shuttles. Therefore, the objective of this research is to understand how the public feels toward driverless shuttles or smart shuttles, to investigate users' perception at an aggregated level by directly analyzing the context of tweets, and also to explore how user perception and views are different in different parts of the world and how they have changed over the time. Next slide, please. So methodology for this, the research we did, it has two main sections. First of all, we are collecting data, we are doing some data management, and then out of that, we are doing some analysis. The data management has three main sections. First of all, we're collecting data. Here is Twitter data, and then we are cleaning those data, and then we are doing some segmentation in terms of temporal and geographical information. And in the analysis part, we are doing first some semantic analysis. It means we want to see what topic people talk about. And then we are doing some sentiment analysis to see what people feels about those topics. And finally, we are doing some spatial temporal analysis to see different people of the world, what is their idea and their understanding about deployment of these smart shuttles. Next slide, please. So for the data, we retrieved tweets concerning just about a smart shuttle service around the world. And in the period of 1st Jan 2015 until 1st October 2019, the total number of tweets we collected within these periods is around 56,000. And we list all of these hashtags. The example of these hashtags are driverless shuttle, smart shuttles, smart mobility, self-driving. We have a list of the hashtags that you can see some of the example here. Next slide, please. So in order to do the semantic analysis, we need to define a kind of lexicon or dictionary for all the categories. And out of these dictionaries, we have defined four main categories or four main topics. And we're collecting some related terms out of these topics for this lexicon. So any keyword from each tweet were extracted and the topics of each tweet was defined based on the following lexicons. And the main category are safety and security, anything related about the safety. If people are talking about hacking or if the cybersecurity, that would be the topic that is going to the safety and security category. And then we have a service delivery, anything related to the performance of the smart shuttle, for example, the speed of that, or what is the comfort, what is the seat availability or service operation in general. That would be the service delivery category. For the information, anything related the public knowledge, about the symbols, about the advertising, anything related to the data could be in the information category. And the last one is the technology itself. In general, what is people are talking about a smart vehicle, about the system, about the intelligent vehicle, about the smart cities, which is related to these smart shuttles. That would be category for the technology. Next slide, please. For the sentiment analysis, for the processing of this textual data, we use some Python library. It provides a simple API for diving into the common natural language processing. And in this package has a built-in default lexicon that assigns two indices ranging from 0, which is telling what is the statement, is a weak statement or negative statement, to 1, which is a strong statement. For example, if people have a kind of a strong statement about any of those category and topic, this could be scored as a 0.9 or something like that. If this is a negative, it could be close to 0. For example, 0.1 is a negative and people have a weak statement about that topic. Next slide, please. For the spatial temporal analysis, we want to understand the general user perceptions, both spatially and temporally. We conducted a spatial analysis, and that can help us to explore the topics that specific interest of different location at various timestamps. Next slide, please. So the results, the first result, which is about the semantic analysis, that you can see from the graph here, the dominance is technology. It's showing us people mainly talking about the technology itself. Around 70% of all the tweets data, people are talking about the technology at this stage. And the least concern at the moment is service delivery, which is about the operation of these smart shuttles. Next slide, please. For the sentiment analysis, the result is showing that although the positive sentiment score outweighed the negative score in the categories of safety and security, service delivery, and information, the overall sentiment is negative. And we can see in the next slide in detail why it is happening. One of the main reasons is that technology is a kind of dominant topic and people are talking much about the technology itself. Next slide, please. If you want to look at the trend, how the people understanding and how people changing about this smart shuttles topic in general, you can see the trend of growing negative sentiment and declining positive sentiment expressed over the 5 years may imply a kind of a skepticism about the driverless shuttles. So from 2015, which is mainly people have a kind of positive sentiment about deployment of these smart shuttles, it gradually reduced and it became a kind of negative trend by end of 2019. Next slide, please. So if we want to see the details for each topic, we see an obvious trend in the technology, which is growing negativity from 2015 until 2019. But in other three topics, there are a kind of balance between positivity and negativity. And also in some of these topics, people much more talk about in a positive side as well. Next slide, please. So for the spatio-temporal analysis, we did analysis for the different location of these tweeters. Number of tweets in a 5-type location is sorted here. As you can see, the United States has the highest number of tweets among countries, followed by UK, the Netherlands, Canada, France, and Germany. Next slide, please. Accordingly, frequency of topics for each of these top countries between 2015 and 2019 is showing that tweets related to the technology of smart shuttles dominated the interest of users, followed by the topic of information. Next slide, please. This is the highlight about those, because the figure maybe is not clear enough. I highlighted about those countries that technology is dominant and then followed by the information. Next slide, please. So the key finding that we found out of this study is analysis is showing that the primary inclination of user is to understand the technology itself at this stage. And our analysis is showing that users' opinion have evolved gradually from generally more positive sentiment in 2015 to being more a kind of negative by 2019, reflecting maybe the transition from people's excitement and facing the reality. But we also want to highlight here, this is the action plan. We need to have a plan to address the user concern and increase public knowledge about the smart shuttle deployment. Here I want to highlight one of our outcome of our stakeholders interview, and they are suggesting that we should kind of define some strategic goals in order to have a kind of business case that is both commercially and socially acceptable. And also I want to highlight here the outcome of this result out of this social analytic analysis. We can confirm that there is a kind of limitations, and every time there is a kind of question about the tweet analysis, because maybe people are using Twitter or kind of tech savvy. But the point is, these analyses are showing us a kind of insight about what is the general understanding of the people about the deployment of these smart shuttles. Over to you, Sipa.
Thank you very much, Mahmoud. That's fantastic. So the outcome, as Mahmoud has noted here, is that apart from all the technical specs that we spent the last 2 years developing and assessing and working with the SAE on and working with our cities on, there's this user perception. And if we go back to 2016 and 2017, if you were around at that time looking at smart vehicles, you will know there was a huge amount of sex appeal around these concepts, around getting these shuttles out on the road, attracting the next generation automotive system, the fact that manufacturers would be keen to invest in cities that launch these shuttles. And there was a lot of belief that users would simply adopt it. There was the sex appeal of Tesla and its automated tech. And that appeal, that attractiveness seems to have waned in the last couple of years per not only Mahmoud's findings, but the findings we're obtaining through our one-to-one interviews with transit agencies, which Mahmoud articulated just previous to the user findings. So when we take the transit agency, city, and core partner interviews and combine them with the Twitter social media analytics outcomes of what users are saying, it is very clear that for CUTRIC, this common procurement, this joint procurement, and this effort very much is going to have to spec out user perception, user opposition potentially, and user concerns, where perception is equivalent to reality in this case. So getting the tech out the door to reduce emissions and improve mobility will go nowhere if we find that our users are waning in their support, their feeling of comfort and security, as the demonstration of analytics from the Twitterverse suggests that they are. So we're scratching the surface right now, but this is enough evidence for us to know that this is a serious issue for the automated vehicles. This kind of sentiment opposition does not appear when you do the same kind of analysis for electric buses or hydrogen fuel cell buses even. Maybe 10 years ago it did, maybe 20 years ago it did, but it doesn't today in that electrified bus world. For automated shuttles, this user sentiment certainly is a core parameter condition to work around. Now we have several questions, and folks, in our original agenda, we did identify a health break. And one of the things that we are known for terribly is not giving people enough health breaks. And so what we're gonna do is take a few minutes here to answer several questions, but we are going to move right into the next portion of the agenda. This is being recorded, and we are going to be posting all or part of this webinar online for our registered participants. So if you do need a health break, you need to take a few minutes, please do so. We're going to continue, however, because we have a lot of information still to cover and we have a lot of questions coming in. So first off, just to identify a couple questions that have been posed. One question is, Lindsay, your question again from the City of Toronto, and it's a question to which I do not have the full answer right now, and it's something we've been discussing on our group, in terms of how we approach it in a post-COVID world. So the question is, while the medium-term future is quite uncertain, it's probable that passengers and operators will need to physically distance for some time, or perhaps on and off over coming years. How do you think that might affect demand for, or the perception of small shuttles, ELSAs? First, I paint the context. We have a COVID-19 transit asset deployment webinar we're preparing in the next couple of weeks to plan for COVID times 10. because this is a terrible pandemic and there's going to be worse ones. And if you're around 40 years old, which is what I am, and you plan to live for another 60 years, which I plan to, then you know as well as I do, there's going to be climate disasters, there's going to be pandemics, there's going to be horrible things that happen where we're going to have to get prepared as a transit network to deploy our assets almost in a militarized fashion as deployable assets that need to be used in these crisis mitigation zones. Automated shuttles potentially play a very positive role in that. And some of our members have articulated the fact that they're designing roboticized automated shuttles to deliver packages in driverless ways where these transit assets could be deployed in a crisis or pandemic scenario or a climate action scenario or wildfire scenario. They could be deployed to deliver much needed medical supplies, food, water, or even to move medical professionals and personnel in a way that our transit vehicles are not currently deployed. Remove the driver and you remove a lot of the concern over putting an essential worker at risk, yet you can still use this transit asset. So to turn your question on the head, to start with, we have been thinking about how can we plan for a worse future and plan transit assets, in particular automated shuttles, as pandemic or catastrophe response mechanisms. So that's response number one. We don't have the full answer there. We're going to start fleshing that out in our COVID specialized webinar in a couple weeks, and then discussing it even more at our national conference, which we have digitized, which will be happening in June of this year. A lot of planning, I think, in Canada has to happen in that space. But then after the pandemic or after the crisis passes, what happens when we either have a social desire to physically distance or a necessary desire to physically distance? That, the second prong of that, we've just started to think about at CUTRIC how we can support the development of technologies, tools, and solutions and procurements for low carbon mobility in a world where physically distancing is needed. The first aspect that comes to our mind is this has not proven that transit will be less popular. What it's proven is maybe that we need a lot more transit. That in preparedness for these scenarios, when we have to eliminate access to 50% of the bus or 60% of the bus or the shuttle, where a shuttle that used to hold 6 people can now only hold 1 person, it may be the case that the philosophical investment needs to lead towards much more of these assets, not much fewer of these assets. That's the starting point of our thinking right now, which is why we're not using the concern around social distancing as a reason to not deploy these technologies. If anything, where I want to get to is us deploying these technologies as a national consortium of partners, showing not only that they work and that they can be deployed effectively in catastrophe scenarios to help humanity, but also that they could be scaled up at the lowest possible cost, not only for environmental benefit, but also in scenarios where we have to accommodate social distancing without degrading people's access to mobility. So we are welcome and open to the idea of shifting our thinking on that if people have good ideas. Our core focus at CUTRIC is not general policy, but technology projects that help humanity and grow the Canadian landscape. So if there are ideas around how these automated shuttles could be affected, could be shaped, and therefore what we need to technically or socially spec into our common procurement to prepare for that, we welcome those. And I think it is a live debate. We need to use this catastrophe right now as an opportunity to really push our minds to the extreme limit of what these assets can do and what they ought to be deployed to do. So thanks very much, Lindsay, for that question. We have several others, and there's a few folks who have made really good comments, and I'd like to turn to them. Now, we've implemented a series of security measures to make sure that nobody can take over our screen or Zoom bomb the line in any kind of way. So we're gonna figure out if we can unmute a few of you. We have colleagues at New Flyer, colleagues at To Get There, that we would like to unmute briefly so that they can give insight into their own integration and technology innovation goals based on what we've said, as well as their experiences. So Robert, Thomas Small, a few of you, we're gonna see if we can one-on-one unmute you in the next few minutes over the course of the next portion of the presentation. If not, then I will come back to your comments in plenary and share your comments with the rest of the group here. Then I will deal with one more question before we move to the next portion of the agenda. Jeremy has a question again about could these shuttles be used for cargo, for example, along King Street, partly for people along with delivery. I think that builds as a nice segue off of what I just articulated. We are looking at the idea of freight movement, but we didn't start with freight because CUTRIC's vision and our mission is to move people. And so we're looking at moving these technologies and using them to move people over distances with less energy, more efficiently in a way that improves their life. Could these vehicles, including any other vehicles out there for that matter that are in the public domain, be optimized during down periods or non-intense periods or non-peak periods? Could they be optimized in order to move freight or deliveries? Yes. That's always been a discussion at CUTRIC for the last 2 to 3 years about how we could look at transit assets and maybe in some cases optimize those empty buses as delivery vehicles where transit actually gets paid to deliver the equivalent of an Uber Eats. Is that possible? Yes, it is. Would it create money for transit? Yes, it would. Do we have the answer for it right now at CUTRIC? No, it's not our primary goal number 1 in this project, but it is hovering around the periphery as a potential goal that we could attempt to accommodate down the road once we get these technologies out the door for the purposes of moving people first. So stay tuned on that one. And with my colleague Lana online, I'm going to see if Lana can unmute Robert Lohman to get there. And we're going to see if we can attempt this, Robert, with you on the line, because the particular comment that Robert has made is that given all these technical specs, level 4, level 5, the size of the procurement, the size of the integration, and the need to really design the urban environment around it and the procurement lifecycle, there are actually pilots now in procurements that to get there won't even bid on because we're past the stage of one-off pilots that go nowhere. We're squarely in the space of integration trials that lead to full fleet procurement or robust fleet procurement. So with that, I'm going to check in with my colleague Lana to see if we are able to unmute Robert so that he can speak those words much more eloquently in his own voice.
Am I
yes.
audible?
Hello, Robert. We hope you are safe in Europe as we are seeking to be safe here in Canada and the US. Over to you if you'd like to articulate your point.
Yeah, so the comment was related to the earlier remark about learning from previous procurements. And my remark was that it's just as essential to learn from the procurement itself as from the people that, from the perspective of to get there, didn't react to certain procurements. So whenever a opportunity comes into to get there where we can take a look at, one of the first things we do is look at the timelines. So what is the time that is being provided to a supplier to actually react to the bid that's out there, whether that's sufficient to make a good bid, and whether the time from, let's say, contracts to actual deployment is also sufficient to actually roll out the system in a way that you can meet the safety standards and are not, how do you say that, just doing a demonstration based on exemptions that you can get from the regulations. So it's both the time to react to a bid that's out there, the time to deployment, and then once it's finally deployed, that it's not a 1 year or 2 year demonstration at a certain site, but that you are looking at a 10-year horizon or even beyond that, and you're providing a permanent transportation service to the residents or the visitors of a certain area. For us, those are critical factors in deciding whether or not we will actually pursue an opportunity or not. So please realize that once you're pursuing your projects, that based on the requirements you set, you might actually be, let's say, not inviting certain vendors to react.
And that's fantastic. Thanks very much, Robert. I appreciate that. In fact, you articulate our sentiment, which defined our electric bus project. It's defining our hydrogen fuel cell bus project. And that same philosophy is coming into play here, which is really, I cannot dedicate CUTRIC labor and time to one-off pilots. There's been a lot of that. A lot of this has to focus on long-term integration with a long-term procurement goal in order to achieve actual long-term mobility transformation. One-off pilots have happened, they've come and gone. There are oodles of data that we can access already, and we don't have to repeat that. And so to the point, Robert, that not all manufacturers or integrators will be able to respond to the specifications that come out of that, that is entirely accurate. And we saw that at the time of our electric bus project. Not all manufacturers could respond, both on the charging side and on the electric bus side. And that is the nature of innovation when you're trying to push innovation to an integration level on a technology readiness scale, where you're trying to get out of prototypes and the first pilot runs in TRL 6 and you're trying to drive the system integration to TRL 9. So I think we are of the same hue on that point, and we welcome feedback from additional stakeholders. We have several additional comments. There is a comment from Thomas Small at New Flyer about SAE J3016, and we have additional comments from our colleagues at IBI Group. To keep on time, we're going to move to the next portion of the agenda, but we're going to check in with you, Thomas, if you'd like to be unmuted on your particular point. And then Doug, we'll see if you would like to be unmuted on your particular set of points around level 4, because there is an open dialogue here to be had about whether level 4 can accommodate traffic control signals, crosswalks that are within a controlled environment, and also inclement weather conditions. Our position at CUTRIC is that yes, those are some of the parameter conditions that can be designed, but there is no doubt a gap in SAE thinking around shared shuttles and what the parameter limitations look like when you're not looking at all conditions, but you're looking at some limitations. Do those limitations include weather conditions, some traffic signals, and some left-hand turning navigation? And so we'll come to your folks in a moment, see if we can unmute you after the next portion of the presentation. So go to the next slide, Lana. The next section of the presentation, we're going to take you through, folks, the ACATS modeling outcome. We'll just go to the next slide. And one more slide. Thanks, Lana. Very good. So for some of you who are transit agency partners, you've received your one-on-one presentation where we shared with you the detailed outcomes of your particular presentation. So for right now, what we're going to do is take you through the generic outcomes plus focus on York Region Transit here today. We picked them in order to look at their outcomes specifically, but there were 9 municipalities that were involved in this project. I'm going to start off on the energy consumption side, and then my colleague Elnaz is going to take you through our preliminary modeling of ridership outcomes. We'll go to the first slide. So first off, this comes out of the Advanced Connectivity and Automation Program in Transportation System led by Transport Canada. Applause to Transport Canada now 3 years ago. The team really thought about getting some pilots out the door, some studies out the door, from standards to modeling to pilot project deployments in order to move the country forward towards connected and automated vehicle deployments. I would say we're all coming out of that period now saying, okay, the party has ended. It's not a hangover, but it's also not sort of the happiest day today, because out of that party of a lot of funding, we didn't get to mass procurements or even substantial procurements in Canada. So that $3 million of federal funding that went into this has resulted in really good lessons learned, but it hasn't resulted in joint procurements. Hence our need for a project that overcomes that gap, our ability to help the federal government get to where it wants to get to, which is a zero carbon economy, in part supported by automated and connected vehicles. We'll go to the next slide. Just to take you through, this full report that we prepared has now been finalized and approved by Transport Canada. It took us over 1.5 years to pull it together. It contains all of these aspects. We're not going to review this all today. We're only going to review the top 2 bullet points. That report is one of our first white paper series. It's not really a paper, though. That's a bit of a misnomer since it's over 150 pages. It's more like a massive white report, but it will be released in the next month as part of our first publication dissemination. Another report following off that is our Natural Resources Canada electric bus best practices, and following that is our Transport Canada Rail Innovation Report. So we've evidently had our heads down, really focusing on research in the last 1.5 years to get these results that now lead to commercialization, technical spec, and planning. Go to the next slide. All of you will receive notification of that report once it goes live online. So to take you through our ACATS project, the project that we won funding for at CUTRIC was to select 9 municipalities, or find at least 9 municipalities. And we had happily 10 municipalities at the time that were ready to participate. We had to find them and ask them what their first kilometer, last kilometer application is. If they had access to shuttles that could serve in a level 4, level 5 environment, where would they put them and for what purpose? And then we had to ask them to give us those route profiles. Some of them were pre-established route profiles that the agency had already been thinking about trying to get a bus service to, but it's too small, so it didn't work. And some were, really legitimate Frankenstein routes, routes where definitely there was no bus service, no thought about it, but boy, if there were a shuttle, that would really fix things. So we first off developed a simulation tool, one of our first generation simulation tools. Our new simulation tool is Rout. I. So I put the logo there. Rout I is our new simulation tool. It's a lot more powerful than the Gen 1 simulation tool. But Gen 1 was the simulation tool we had built out into 2018, and it did the job. In the words of Barack Obama, what we can do now is use a scalpel where previously we used an axe. This is the axe. So we're going to present to you the outcomes of the brutal blunt force modeling work that we did. Now going forward, we're going to be refining a lot of this into much more precise outcomes, but nonetheless, it did the job with the technical specs that were available, and it gave us all a sense of reality of the art of the possible. So first off, we developed an energy consumption simulation tool in Python that allowed us to model out the powertrains of these various manufacturers' makes and models of vehicles. We then integrated the state of charge assumptions that the OEMs let us to utilize. So how depleted could the battery get before you're hurting the warranty or the life cycle of the battery, what the charging times would be, and we integrated 2 shuttle makes and models for a comparative assessment for our transit agencies. We'll take you through to the next slide. Here, the criteria for assessment, we said to the cities, look, don't give us just any route, because some of the routes just are not feasible for these low-speed shuttles, or they're unlikely to be deployed because you're asking for the world in terms of SAE level 5, and the technology is just not there, nor is the urban design. So first off, we focused on first kilometer, last kilometer applications. Very much, we said 1,000 meters. Now, some of the agencies came back with asking for 1,500 meters or 1,800 meters, and we said that's okay. In a couple cases, it was under 1,000 meters. In one case, and we'll show you the comparative in Brampton, it was well over 1,000 meters. It was over 3,000 meters, so 3.5 kilometers. And you'll see the outcomes in terms of energy consumption and state of charge depletion. So we're really trying to hone in on the 1 to 2 kilometers. And the reason is that once you get beyond that, we have transit routes that are 4 kilometers in length in Canada. Now, they are usually interlined with other routes, but nonetheless, once you get to 4, 5, 6 kilometers, you might have a bus that's applied to that eventually. It might be a small shuttle, it might be a small bus, but it's in the bus domain. And we definitely did not want to get into competition with bus applications or bus drivers. So we're looking at routes where it's annoying for a North American to walk. It's 1,000 to 2,000 meters. It's just long enough that if you don't have a shuttle or something to ferry you from point A to point B, you might just get in your car and drive the whole way, not the 1 kilometer, but the whole 30 kilometers, because you're not going to bother going to the train station or the rapid transit routes. That 1 to 2 kilometers is the annoying piece that leads you to go into your car when you would otherwise take transit. But more importantly, from a social equity standpoint, it's the distance that is extremely difficult if you are a parent with a baby carriage, or you are somebody who's trying to carry groceries. I myself, I consider myself reasonably fit. I'm not perfect, I'm reasonably fit, although I ate a lot of cookies this weekend. Nonetheless, reasonably fit. I don't have a car. And I do walk to the local No Frills, and that local No Frills is 900 meters away. And when I do my grocery shop, it annoys me. It's hard for me to carry 3 or 4 bags of groceries back home. So that's me. Imagine I had a baby carriage with 2 kids, one of them running off onto the street, and I'm trying to manage this and carry my groceries. Very difficult. And then we're also thinking 1 to 2 kilometers is a distance that a senior or somebody with mobility problems is going to really struggle to overcome, especially if you have a cane, a walker, a wheelchair, anything that is going to stop you from getting to the transit hub. So there's a social equity component embedded in that 1 to 2 kilometers, as well as avoiding competition with transit drivers. The max grade that we accepted was 6%. That was guided by our manufacturers and some of the lessons learned out there. That max grade may have changed since we started this study. It may be possible that greater grades are potential, possible, feasible, but that's what we limited ourselves to at the time of this study. And then we identified with the agencies, is there a legitimate possibility that you could, in the near term, build a dedicated laneway? So not a super highway, not a massive construction project, but something like a slightly elevated or at least divided, expanded bicycle lane for these shuttles in the future. Otherwise, we're spending money, federal tax dollars, simulating and modeling a route that you're never going to apply a shuttle to, because there's no chance that you're going to even partially dedicate the laneway to these shuttles. And not in all cases did we get that, but in a lot of cases we got a route that transit folks and cities were open to possibly putting some dedication and laneway divide around if the shuttle could show that it could do it, and if we could show the ridership was feasible to warrant that investment. And then of course, the last point is no current or proposed transit service, because not only did we not want to compete with drivers for obvious reasons, but we didn't want to go through this effort and spend federal tax dollars to simulate a route that's getting a bus next year anyhow. So those were some of the parameter conditions we had in place. We'll go to the next slide. Here, we're going to take an example. There were 9 cities, but we're going to focus on York Region here today, largely because York Region is a great example of a route where it's needed to move people to a hub, a route in a community where car congestion is a problem. So it checks all the boxes of it is under 1,000 meters. It is within the zone that York Region Transit operates in. There are 5 stops proposed, 1 at the start, 1 at the endpoint, and 3 along the way to pick people up or drop them off. It is definitely within that first mile, last mile, though we really should use first kilometer, last kilometer. And the reasons for picking the route is that the route links the Maple GO station to its nearest neighborhood. And a survey was conducted at that time by YRT, identifying that most of the cars that parked in Maple Station were traveling from a distance under 5 kilometers. And so that was quite interesting to us, because that very much identified the fact that this is a route and an environment where people are choosing to get in their cars to get to the GO station, or maybe even worse, get in their cars because they can't get to the GO station easily and drive the whole way into town or over to Mississauga or to the airport or wherever they're going. And so it was very well empirically backed that this is a really good route if we could get a shuttle going in this system. We'll take you through to the next slide. So in terms of our modeling methodology, first we generate the speed profiles on the selected route. We create the topography, usually using DEM data, and then diving deep. Sometimes we use satellite imagery where we don't have sophisticated DEM data, or if the resolution's not good enough. Then we calculate the energy consumption of the shuttles using OEM proprietary data. So thank you to our manufacturers that provided those sets of data, as well as the manufacturers of the charging systems. They provided the sets of data about how efficient and how powerful the charging systems are. And then we modeled it out using 3 case scenarios, a light duty, a medium duty, and a heavy duty, to show some variability of what happens when energy is heavy and what happens when energy is light in terms of payload. So we'll go to the next slide. Oh, we skipped 1 slide. If you can go back 1, Alana. There, in terms of energy consumption modeling, lots of variables that go into our model. Now, this was, of course, our Gen 1 model. We have added variables, refined variables since this time. But generally, if you take a look at this, these are some of the variables that go into our algorithm that we built out. Everything from the tire radius and the gear ratio to the frontal area, the rolling coefficient, the motor efficiency, the converter efficiency, the weight, the motor torque mapping, and the max passenger load. Not all cases did we have every single variable. So this is why I say not only did we have our Generation 1 algorithm, which was reasonably good at the time for what it needed to do, but we also didn't have all of these data points from all of our manufacturers. Sometimes it was very proprietary and people were concerned about sharing. In other cases, it just didn't exist or it wasn't available at the time that we were asking for it. So lots of reasons why we might have not had perfect sets of variables in all cases. This is partially why we need to redo the modeling, but I don't actually think even when we redo it that we're going to see massive changes in energy consumption for the reasons that I'll articulate in a moment. We'll go to the next slide. So if we take a look at energy results, we're just going to show you some examples here. TR stands for Trois-Rivieres in Quebec, BR stands for Brampton, and YR stands for York Region. So actually, we should have highlighted York Region here. Sorry, we highlighted Brampton in this case, but nonetheless, you can see York Region compared to Brampton, and you would have seen the map that was identified by York Region Transit heading to the Maple GO station. If you take a look at the first manufacturer, which carries more passengers, and there's a second manufacturer that we modeled that carries fewer passengers. If you take a look, you can see in the first manufacturer deployment, whether you're in Trois-Rivieres or Brampton, York Region, specifically, let's think about the map you just saw in York Region. In a medium duty cycle, it's about 0.43 kilowatt hours per kilometer for this shuttle to move. In the case of the second manufacturer, it's about 0.34. So they are differential, but the reason for that differential is the size, the weight, and the number of passengers. And so what we've been able to say to our transit agencies is really there's going to be a balancing act. how big do you want the shuttle versus how much energy do you want to consume per kilometer, and how big do you want the shuttle to move how many people. There's a cost profile associated with larger shuttles. There's a cost profile associated with the battery pack. There's maybe even a cost profile associated with higher power charging. But if you have a bigger shuttle and you have a bigger battery pack and you have higher power charging, you move more people in the same period of time. So what is the goal? Is it to move a maximum number of people, or to hit a certain sweet spot of price point versus moving people and GHG reductions in your particular environment? We don't have those algorithms yet. We don't have a perfect set of equations that show us where the inflex point is for each agency. This was a first effort to show that there is differentiation in the energy consumption, but not so much between the different OEMs. More what we wanted to show agencies was it's based on the route and your route profile that is primary driver of the energy consumption. So you can see Brampton, if you take a look at medium duty, Brampton compared to York Region, the route that Brampton chose compared to the route that York Region chose is about twice as energy intense. Well, that makes sense because the route that Brampton chose is about twice, actually almost 3.5 times the distance of York Region's. So that's actually a pretty good outcome. Brampton's route, if it was just a linear calculation, would be at least 3.5 times more energy intense. So it means that possibly there's more topographical considerations in York Region. Perhaps there's more gradient, there are more stops and starts. There's other things driving the energy consumption in York Region per kilometer rather than just the route length. But your route length, your topography, your ridership, and the number of stopping and starting are all going to drive your energy consumption, which drives the number of times you can do a round trip, and we'll talk about that in a moment. For those of you who haven't seen our modeling before, our first generation modeling, as well as our latest Route I modeling, has 3 duty cycles. The light duty cycle assumes the vehicle is empty. There's nobody on board. So it starts at point A, it gets to point B, which is the end point. It makes none of the stops that are prescribed for it. It basically travels at constant velocity with nobody on board and no auxiliary load. Medium duty assumes that 50% of the maximum load of the vehicle is replete. So if the vehicle can hold, say, 10 passengers, we assume 5 passengers of an average medium-sized man in North America, which is an assumption, and it's one we will modify going forward, but it was the first round of modeling. And so then we also assume that auxiliaries are 50% turned on. So whether that's heating or cooling or any other auxiliary, ancillary, or parasitic loads, that they're 50% turned on. We're very dependent there on manufacturers telling us what those loads are. And then in heavy duty, we assume that the vehicle is fully packed to its max capacity. Its auxiliary services are turned on, or its auxiliary sources are turned on for maximum energy consumption. And it's making all prescribed stops along the route. I should have mentioned in medium duty that we assume 50% of stopping. So if there's 6 prescribed stops, we would calculate a random 3 out of those, the start point, the end point, and a random 1 in between the other 4 in that stopping and starting. And so that's how we generate our medium, light, and heavy duty cycles to see a range of consumption for agencies. When you apply this to electric buses or heavy duty hydrogen fuel cell buses, the outcomes are really powerful because of course each of those buses is $1 million approximately. In the case of these shuttles, the cost point is less, but they're not free. They still cost quite a bit of money if you compare them to not putting anything on those roads. And then you integrate the cost of the energy charging system. There are costs here. And so that balance point has to arise, determining how many people are going to move for how much energy per revenue kilometer. If we go to the next slide. If we take a look at the comparative model here, then when we take a look at all of the cities, we had Calgary, Trois-Rivieres, through to Brampton, Alberta, Vancouver, York Region, Montreal, Quebec City, and sorry, I skipped over SR, which is Surrey. We take a look at the routes that they provided to us, east to west in Canada, west to east. You can see Brampton's was the most energy intense. Quebec City came thereafter, not surprising with its hilliness. And then everybody else was more or less in that 0.4 to 0.55 zone in terms of kilowatt hours per kilometer. But again, it's not that the topography of Calgary in general is driving this or the topography of Brampton. It's the specific route, that topography on that route, the assumed ridership in that environment, and of course the length of the route. So that's what's driving it. You can see that your first kilometer, last kilometer selection is really going to have a huge impact on the exact same shuttle's energy efficiency. So the same shuttle operating in different environments is going to have a very different range. And this is a large message we've shared in the electric bus domain. There's really no such thing as range anymore. Range is highly dependent on the route and the topography and the ridership profile you expose that vehicle system to. And you can see here, these are all the same shuttles modeled out, but very different energy consumptions per kilometer based on the local conditions that they are applied to. As you will have seen from York Regions, it's very much first kilometer, last kilometer to a GO station, which is an optimal application. Help people get to the backbone of a mass transit service. There are other examples, and we will come back to Calgary at the next session. We're going to ask them to share all of their lessons learned. Calgary Transit had a route that I still love, largely because I'm a Calgarian. And so that route goes from the Zoo LRT station in Calgary to the Spark Science Center. There is no bus, there's gravel road, there's a bunch of parking lots. They created a dedicated laneway to move people from the LRT to the Spark Science Center. That is a very specific type of route. It's also a great first kilometer, last kilometer. Because there is no way to get from LRT to the Spark Science Center, most people drive, which is why the Science Center is surrounded by a moat of parkade and parking lots. And as somebody who takes her niece and nephew to the Spark Science Center all the time, when you have a baby carriage and it's winter and there's no pedestrian walkway from the LRT to the Spark Science Center, you are very much inclined, despite being an environmentalist, to drive your car the whole way for safety. And so that's a great application, moving people to a transit backbone or moving people to points of interest for the purposes of social equity, all excellent first kilometer, last kilometer applications. So I think we had a Hank Wang, you had a question, and Doug Parker, you had a question about some of the types of applications. These are some of the types of applications we were seeing. In Quebec, in Trois-Rivieres, we saw applications through a local community. We also saw an application through a local community, very much like York Region. We also saw an application into a park in Trois-Rivieres. And so that was also very interesting, offering a mobility service into a park that normally has nothing. And therefore, if you have a walker, a cane, a wheelchair, you usually can't travel too far in that park because you have to walk. So also highly reasonable applications. No airport routes are proposed here. A lot of our airports have now come forward and said, here's our specific employee pathway application. So we'll be looking at that going forward. Go to the next slide. If we then compare the performance of the shuttles, in this case, we had OEM 1 and OEM 2. This is kilowatt hour per kilometer per person. You can see that in some cases, OEM 1 is more efficient. In other cases, OEM 2 is more efficient. And that is because the topography, the ridership, the stopping and starting, based on the algorithm we had developed, and we still see this today when we do it for electric buses, sometimes it takes the powertrain out of the sweet spot of performance. And so maybe combination of the load, the speed in that particular environment, the gradient, takes the motor and the powertrain into an inefficiency zone, so it becomes a little bit less efficient than its competitor. But mostly what's driving this is not exiting the sweet spot on the powertrain. Mostly what's driving this is how many people on board the vehicle in that community. So there's the vehicle max capacity, and then there's how many people did we think in that community would actually get onto the vehicle. And so part of this per kilowatt hour per kilometer per passenger is really being driven by a combination of the powertrain performance based on the specs we had at the time with how many passengers are actually on board the vehicle traveling what distance. And so the distance, number of passengers, plus powertrain efficiency curves, where that combination of variables is leading to not a linear environment where one OEM is always more efficient than the other. And so really trying to procure based on which OEM is developing the most efficient kilowatt hour per kilometer per person powertrain is probably going to lead you down not the best procurement scenario. What you really have to look at is how many people do you want to move in a community for what purpose. A lot of this differentiation, if you look at the actual quantitative values along the y-axis, is minimal. It's between 0.03 and 0.05 kilowatt hours per kilometer per person. This is not going to break the piggy bank in terms of the kind of procurement you do. If it were electric bus domain, where these things are traveling 100 kilometers an hour and 600 kilometers in a day, different story. But in this environment, really you're gonna have to look more not at the kilowatt hour per kilometer per person, but at the what do you wanna move over what time period and what kind of community. Go to the next slide. If we then look at the comparison of state of charge, similarly, we don't see mass difference between the shuttles because whether it's big or small, there are some efficiency differences in terms of the weight that they're carrying. So that will show up. But at the level we're talking about here with the very small routes, we're not seeing massive differences in heavy duty scenario even with the auxiliary services turned on. We're not seeing a huge difference in the state of charge drop on the one-way and then round trip delivery. We do see it in Brampton, and in part that's because Brampton the route is very long. And so because of the Brampton environment and what they selected, it is actually driving a state of charge differentiation in terms of the two shuttles as a comparative. But more or less, we're not seeing a massive differentiation between the two shuttles' state of charge. If we go to the next slide, and I should say the state of charge is also driven by the average speed or velocity of the roadway that the vehicle is applied to. So part of the deep dive analysis shows that when you have a dedicated laneway and you set the speed limit, and that speed limit is low, it's between 10 and 20 kilometers an hour, you're going to get optimal efficiency from the powertrain. Take the same vehicle and apply it to something that's 50 or 60 kilometers an hour, which some of the routes had, in particular in Brampton, higher speed application, then you're going to see a lot more energy intensity and energy usage. So if we take a look at charging time, that then all has an effect on charging time. Take a look at York Region. If this is the charging time in minutes on a one-way, so the vehicle in York Region starts at its starting point, gets to the end point. So it goes from the Go Maple Station to the end point where it turns around and comes back. It is going to need 0.3 minutes if it charges up en route. So this may lead an agency to decide no need for en route charging. And so that is something to consider. But if you take a look at the Brampton case, it's going to need 2 minutes for the first OEM. It's going to need 19 minutes for the second OEM. And you might say, well, how is that possible, Josipa? Because OEM number 1 carried more passengers. OEM number 2 carried fewer passengers. How is it possible that you have such an increase in the number of minutes of charging? It's because these two manufactured products do not charge at the same power levels. There is no common charging for these vehicles right now. And so OEM number 1 is a bigger vehicle and it does carry more people. And it may be more expensive than a smaller vehicle with a smaller battery pack, but it also charges at a much higher power level. And so system design thinking comes into play. You may not be driven by the price point or the size of the vehicle in terms of its battery pack, I should say. You may be driven by the charging time and the fact that you need to drive down the charging time to fit a particular transit schedule, to fit your GO train schedule, or you need to fit another rapid transit way schedule that you're trying to achieve. So this is part of the variable analysis you want to take into account. If you take a look at the time to complete a single trip, in both Trois-Rivieres and York Region, you're around that 3 to 4 minute mark one way. In Brampton, it's about 11 minutes. So you can tell right away the difference in distance here. And if you tack onto it charging each way of a half a minute to 2 minutes, that might seem reasonable. Now there's a cost to a high powered charger, and that cost is ratios, orders of magnitude less for a lower power charger. OEM number 2 uses a lower power charger, a lot cheaper, but then you have to plan out in Brampton that you have a 10-minute one-way and you might need 20 minutes one way to charge up if you charge up en route, or you are in York Region and you have a 4.5-minute one-way and you need 3.5 minutes rather one way to travel and 4.5 minutes to possibly charge. Or if we go to the next slide, you decide that en route charging is not needed at all. And instead, you're going to see how many round trips that you can achieve before the state of charge is depleted to the level that the manufacturer guided us to use. No battery should deplete to 0%. You want to protect the battery health. And so using those specs, we embedded it into the model. In the case of York Region, this vehicle, OEM1, can do 61 trips before it has to return with a depleted state of charge. In OEM number 2, it can do about 65 trips. And you might say that's quite comparable. Yes, keep in mind, they carry different numbers of people. So you're moving a different number of people despite the fact you have a comparable number of round trips. Again, systems design, system thinking, what's your end goal? To move most number of people to have most amount of shuttles on a fixed or on-demand route. Considerations for us going forward as we build out the tech specs of this project. Go to the next slide. If we then take a look at the hours, using again the specifications we were provided, using the topography, local conditions, ridership, etc. Then if we take a look at York Region, it is about 3 hours and 45 minutes for manufacturer number 1 to charge up from an empty state, or rather my correction, the service time before battery depletion is about 3 hours and 45 minutes. That's not the charging time, it's the service time. So the shuttle can be out there for just under 4 hours in a medium duty mode, moving those people. And for OEM number 2, it's about 4 hours as well, that it can be out there in medium duty mode in York Region, ferrying people from the Go Maple station to the endpoint or one of the stops in between on that 5-stop route. That means that in an 8-hour day or a 16-hour day or a 24-hour service, you're going to have to think about how many shuttles. And then if you deplete it to a 0 state of charge or near 0 state of charge, the minutes to recharge, which at this point, certainly for OEM2, then becomes the dozens of minutes and into the hours. And if you're taking a look at OEM number 1 at a higher power charging system level, it is dozens of minutes potentially that you have to plan for in downtime if you drive down the state of charge to 0 or near 0. Go to the next slide. Therefore, we have some considerations and lessons learned. Now, the modeling work we did, it has a lot more detail in it. For today, we just gave you the high-level brute force overview that's driven some of our thinking in our common procurement standards. And that full report with all of the details of how we got to these outcomes is being released publicly, as I noted, in a couple of weeks. Our goal was actually to release it last month, and we were getting ready to release it, and then COVID happened. And our sense was if we released it, it would not be recognized. People wouldn't read it. People had more emergent things to deal with, frankly, than reading a detailed report about automated vehicles. Fast forward to a couple weeks from now, we feel that now is the time is ripe. The dialogue has to happen, especially if we're going to try and convert that into a stimulus package request on behalf of our cities. So some of the lessons learned, low traffic is optimal because some of those roadways where the proposed pathway hit a road that had a posted speed of say 50 kilometers an hour really drove the energy consumption of the vehicle. So we recommend lower speed routes, at least for this first integration trial. And frankly, in a lot of residential environments, it is possible to achieve, including say in Toronto, where some speed limits are being reduced right now. So possible to achieve. Low roadway gradients, still ideal. Even if the technology is possible to deal with higher gradients, you're going to consume significantly less energy at lower gradients. And then from a charging, transit scheduling, or fleet scheduling and fleet alignment perspective, higher power is a lot more useful from that perspective. It may have its downsides in terms of cost, civil works, cost and civil works being primary ones, but nonetheless, from a transit scheduling and moving more shuttles in a shorter period of time, it has its benefits. Something to consider given the balance and the inflex point between how many people we're moving, what the cost of it is, and what kind of application this is all being applied to. So next steps for us, we're rerunning our feasibility studies based on the Coalition of the Willing here. And we have put in this bid to the federal government to ask for the money to do those feasibility studies to underpin the business case for moving in this direction with updated OEM technical specs. A lot has changed since 2018. A lot of these technologies have improved massively, including among our partner manufacturers such as Navia, and to get there. To validate those feasibility modelings now with the empirical evidence. So when we were doing this in 2018, 2019, a lot of the empirical evidence was not coming out. There were little bits here and there, but now we know Calgary has a full slate of empirical evidence. We know our manufacturers have full slates of empirical evidence. We know our American partners have projects that have come and gone, fully been completed, and the reports have been published. So we have some empirical validation data that we can now integrate into the updated feasibility studies to see how far off are we in terms of prediction. And if we're not that far off, great, we now have the basis for a legitimate procurement tool. Go to the next slide. So if we move through then here in terms of the York Region route, this is essentially what it looks like. And I'm gonna now turn to my colleague Elnaz Abtalebi. She's gonna take you through the ridership outcomes of this particular first kilometer, last kilometer route.
Thanks, Yasapa. Okay, so in part 2 of the ACATS study, we conducted transit ridership impact analysis model for actually basically for those routes that were somehow connected to current transit system, because the idea here is to improve connectivity and promote public transit, the existing public transit system. So again, York Region route is an example here. This is a perfect example for first kilometer, last kilometer applications. This since this route that was provided to us by York Region Transit Agencies can connect like the nearby neighborhood to Maple Go station. This is the GO line that connect North GTA to downtown Toronto, and other than there is no other modes to connect people that are living in the neighborhood to the current station. There is actually a problem of finding parking spot. I myself was passing by this station every day at the time I was commuting to work, and the parking lot is always full. If you get there like after 6:30 in the morning, there is almost no chance of finding a parking spot. So this is another problem, and that's the case with the prior stations as well, where I get on the GO train. So as you see in the map in the right hand side of the slide, so we got this route that is shown in dashed line, and the actually stations or stops are shown like in green sign, and we actually got the number of houses that are within 200-meter radius of this route, since we thought these are the people that gonna use this shuttle to get to Maple Station once the shuttles are in operation. And we count the number of houses, and we got 583 houses close to this route. And also we got the area of parking spot, the parking spot that people drive there and park their car there to use the GO train, to be able to find out how many parking spot or parking area can be reduced once we can move away people from the car and have them to use the shuttles once the shuttles are in operation. Next slide, please. Okay, so in theory, we expect that once the shuttles are in operation, more trip will be generated in general, since elderly, those people with disabilities, those people that don't have any license or don't have access to car, they find a new way to get or connect themselves to the current transit system. And since there wasn't, as Josep already mentioned, no empirical data available to us at the time of this study, we have come up with a few scenarios, as you see in this slide: low ridership, expected ridership, high ridership, and unrealistic ridership. These are 4 scenarios that we defined, and we define some assumption that use as a base for our calculation. In low ridership, we assume 5% increase in total. Again, in the existing transit ridership, in the case of York Region, the existing transit ridership that we found at the time of modeling was 14%. So 5% increase resulted in 19% transit ridership. With expected ridership, this is CUTRIC preliminary assumption, as already mentioned during this slide. This will result in 24% ridership in the case of York Region. And similarly, with high ridership, 15% increase result in 29% transit ridership increase, and unrealistic ridership is 50% increase, which result in 74% increase in transit ridership. So these are like scenarios, and we want to get a range of increase in transit ridership in general. And with assumption number 2, we just want to see what percentage of transit riders going to use the shuttles once the shuttles are in operation. So again, in these 4 scenarios, we had 5%, 10%, 25%, and 100% in each of those scenarios. Next slide, please, Lana. And we also got some other information for all these routes in terms of average family size per household, number of housing units, so with that, we could get an estimated population of that specific neighborhood that the shuttle is going to operate. Also got an average number of vehicles owned by household, and existing transit ridership, as I just mentioned, in each of these routes. In the case of York Region, these results are highlighted. So with this methodology, I'm actually not going to go through like the details. These are, you can get the details of methodology once the report is published, but just a high level result. If Lana, you could go to the next slide. So this is the results of this transit ridership model. So in each of these 4 scenarios, we got number of people using transit in that neighborhood. This is the result for York region again. People that going to commute using the shuttles, we got the number of people that going to use the shuttle, number of cars that going to be reduced once people switch using shuttles instead of their private car, and parking space that's going to be reduced. We calculated it to see how much parking area can be reduced, which can be allocated to other purposes, land purposes, and number of shuttles that will be required. And we got this for both OEMs that we work with to see how many of those are needed to move that many people that we model out in this study. So these are the high level outcome. For example, in terms of expected ridership, we see that 108 number of cars will be reduced from this neighborhood, and just over 1,000 square meter of parking area can be reduced, which can be used for other purposes. So with that, I'm just gonna turn over to Josepa. And Josepa, if I'm missing any points you wanna add?
Nope, that's perfect. So we'll just go to the next slide, Lana, because that's essentially taking folks through the high level modeling outcomes. As I said, the report we release has a lot more details based on the best information we had at the time that we did the simulation and at the time that we reviewed the simulation last year and then prepared the final elements around cybersecurity, et cetera. It's really driven a lot of our thinking. We also know that we do need to redo some of the modeling, not only because specifications have changed and route thinking has changed at our agency partners in terms of where they would apply these vehicles, but also because we now have costing profiles we can work with. 2 years ago, there wasn't a lot of solidity around the cost of the systems because you had to think about not just the vehicle and the charging system, but the civil works and the build out of a dedicated or semi-dedicated laneway, as well as the roadside units that would be necessary to operate these things if they are more than just autonomous, but also connected for safety and security. So combining the autonomy components with the connectivity components, where we were stuck was really figuring out how can we build out a DSRC system that enables a higher level of safety and security through connectivity layered on top of autonomy. And it's part of the reason why we've tended towards DSRC, because if we're thinking of dedicated laneway and semi-dedicated laneway, we need a limited number of roadside units, which means roadside units that help these shuttles navigate crosswalks, pedestrian crossings rather, 4-way traffic lights, 2-way traffic lights, stop signs, yield signs, and anything else where a roadside unit would really truly help connect with the vehicle, connect with the infrastructure, and ensure that the autonomous properties of the vehicle are not the only thing driving its security and safety. So we're gonna come more to the connectivity elements at the next couple sessions as part of tech speccing, but that's what we're really looking at, is not just autonomy, but connectivity of these shuttles in dedicated parameter limited controlled environments to move people efficiently and effectively. What we didn't have, as I said, was not only all the tech specs around that, but the costing profiles. Fast forward to where we are now, we have some more costing profiles, so we can in the next few months and certainly in the next few weeks start to identify more appropriate budget asks for what this would look like if in fact the taxpayer became an investor in moving this technology forward. So with that, we do have several questions and we still have 5 minutes before we move to the next portion of the agenda to keep on track. Now there's several key components and comments that were made about J3016 and there were questions about bus manufacturers and their engagement. We have our colleague on the line, Thomas Small, and I'm going to ask Lana to unmute Thomas at New Flyer. And Thomas, I think we can hear you. So over to you if you'd like to make your comment and recommendation.
Hi, can you hear me?
Yes, we can. Thanks, Thomas.
Perfect. I guess the one thing that I had noted earlier in my comment was when we just started discussing the operational design domain. That's actually one of the key definitions inside of J3016, but it's important to note that you have an attendant, we consider attendant on board, and you actually gave a very good explanation of the operating design domain. But when we look at that, we look at the areas where the actual vehicle is operated, and just in reviewing the what you've labeled as that first mile and last mile parameters for selection of the vehicle, that's actually really good. But when we look at that design domain, it includes many factors, not only top speed, the the route it's following, but the weather, the time of day, anything like that is part of that. Where we see in our automated bus development right now is where we're defining that, and where level 4 would fit into those operating design domain, meaning that you can have a route that has many parts of it, and you only segment it where it's automated. So, for example, when you're on a BRT dedicated driveway, that's a level 4. But when you have to leave that and you go into a more heavily populated, traffic-driven, what have you, you would then default to the driver or the attendant that's on board. So there's just some kind of examples of consideration that the operating design domain is important when you define your vehicle route. Us as New Flyer having 35, 40, and 60-foot heavy-duty vehicles, not the small, low-speed shuttles. This is something we're considering as we limp into the technology.
Thomas, that's a fantastic point because it did come up at several of our sessions in the past, both in smart vehicles and in e-bus. And in the e-bus environment, where we're trying to get these electrified vehicles as optimal applications along rapid transit ways, could you automate them to really get like the powertrain operating in its specific optimal zone in a way that's not dependent on the driver's heaviness on the pedal or lightness on the pedal? And then when it gets out of that rapid transit way, as you said, the driver takes over. So it's a default to the lower level of automation, let's say. In this environment, when we started thinking about the application of smart vehicles, we wouldn't necessarily have that luxury of reverting to a driver in the mixed traffic environment, because a lot of the shuttles are designed without a driver, not even a driver's seat, right? And so as a result, if we're assuming that there is no driver that could take over, then that limits our ability to deploy these things within a design environment where for a portion of it it's automated and a portion of it it's a driver. That may actually drive a dialogue with our manufacturers, Navien, to get there. Is it possible to do that, and is it desirable? Or can we find routes that, given the short distance, wouldn't have aspects where they cross into mixed traffic, so they wouldn't need to default to a driver taking over? Great comments, and I'd love your commentary on that, because we do have a couple additional comments cropping up on the Q&A about this.
No problem. I thank you for the opportunity.
Yeah, that's very helpful, Thomas. Thanks so much. And so with that, I'm going to turn to our colleague, Doug Parker at IBI Group. Doug had a number of comments about the exact same issue with level 4 operational domain elements, considering stop signs, traffic signals, and of course, inclement weather. One of the projects that we actually are funding as part of our smart vehicle cluster that Elnaz alluded to earlier is a project at University of Quebec in Trois-Rivieres. Their sole purpose, the researchers who started this month to do their work, their sole purpose is to figure out whether these shuttles under level 4 with some additional connectivity support could navigate inclement weather such as Quebec experiences in the deep of winter. So we have a research project. Those deliverables are going to start to flow our way in the next couple months and into the next year. It's a 12-month project. And we are seeing, to the extent possible, could level 4 be sufficient to inclement weather parameter controls put into play. So Doug, I'm going to turn to you because you had a number of comments about that, and we'd like to hear your perspective since you've been active in this planning process.
Thanks. Okay, so since I asked the question, I mean, a number of the comments you've made, and in particular the comments Thomas just made, sort of touch on some of these points. But yeah, I raised it originally, or was highlighting it originally, because inherently with level 4, there's a wide continuum there conceptually. I mean, it means you don't have a driver, as you were saying, and it means that it's not level 5 where, you know, that driver, that vehicle would just be able to drive anytime, anywhere, under any conditions. But there's a continuum there. You know, there's a continuum of capabilities for a vehicle, what they call it operational design domain, and it's going to presumably increase over time. The vehicles will become better and better, but at any given time, like where we are today, essentially the route and the characteristics of the conditions the vehicle is going to encounter are going to need to be constrained by the operational design domain that's feasible and available with the vehicles of today. As you say, augmented by maybe DSRC and sensors. But so you originally referred to a dedicated laneway, and I just originally wanted to make sure that we at some point talked about how, you know, it's essentially more complicated than just simply a dedicated laneway in and of itself wouldn't achieve anything more than meaning you wouldn't have vehicles ahead of you, and I guess could choose the speed you drive at. But in a real world operation, there's going to be intrusions from pedestrians, bicycles, micromobility, you know, the unruly people. There's going to be various weather conditions, and there's going to be just a lot of different conditions that the vehicle actually has to deal with, in particular the intersections, you know, having to traverse through an intersection. So yeah, so maybe the sensors can help somewhat with that, and it's like I just say, a dialogue with the manufacturers of what can be achieved. But ultimately, a dedicated laneway in and of itself probably isn't going to be quite enough.
That's great.
But yeah.
I think, Doug, you've articulated a good point, and I should underscore the fact, you know, moving to a dedicated laneway was a hard fought battle last year for us, arguing with in a positive way, in the way that we do, arguing for the idea that if we leave it to open mixed traffic in all conditions, it's already extremely complex. Adding that layer renders it impossible for us to launch. Now, the dedicated laneway is just past stage number one. After that, it's all the other elements. Having said that, we're super optimistic. I mean, as Canadians, we've already dedicated laneway and started to get into the movement around bicycles and pedestrian pathways. It's not happening everywhere. It's not happening across suburbia, and it's not happening even in all of our urban cores, but it's starting to happen. And the multimodal movement is helping us to get to a place where people are much more amenable and open to the idea of some dedicated laneway if the infrastructure cost is not massive. So I appreciate your comments, and we thank them for you. We thank you for them, rather, a tired brain. But we'll move to starting the next portion of the presentation, just noting that John Ulakovich had another question about, does the number of passengers offset the cost? And the answer is yes. I mean, it's part of why we're identifying revenue passenger kilometers, but we didn't have enough information at the time of doing this to really do a good apples to apples comparison. Now would be the time to do it because there's much more robust costing profile information. So onward to the next and final aspect, or rather the penultimate aspect of this presentation. It is summarizing for you the Smart Vehicle Joint Procurement Initiative. There is, again, the pre-COVID, post-COVID. We're continuing the project planning as though COVID hasn't happened, while also continuing as though COVID has happened. And what I mean by that is we're not abandoning the idea that we may return to a time very soon where government simply cannot fund everything. And in reality right now, every government, including Canada, is racking up more debt than any generation has known, probably even more debt per person than World War II, or very much nearing it. I haven't seen the latest figures, but we're getting towards that if we haven't gotten there already. So at a certain point, the reckoning has to occur. And as taxpayers, at a certain point, there's going to be a limit to what we can pay for. And all of the debt needs to be paid back in some way in an eventual future. So it is feasible to consider that there may be a time when transit spending needs to be optimized again through financing operations models. And so therefore we're continuing with this initiative because I believe that that time has not disappeared. I believe that there's going to be opportunities right now for funding to get economic development and stimulus out the door, but that window is probably a 12-month window maximum, if not less than a 6-month window. And if we're in the pipeline with a good initiative, that can work for phase one. But as per all of the dialogue we've had this whole past hour and a half, the goal is not to stop at phase one. The goal is to get more and more first and last kilometer routes resolved, so fewer and fewer people are driving in Canada by 2025, 2030, 2040, 2050. So I have no doubt that innovative financing plus funding models are necessary and requisite. So we'll move to the next slide to summarize for folks the initiative that we're moving forward with. We have done a series of board-level strategic planning efforts at CUTRIC, as well as membership-driven and staff-driven strategic planning. We turned 5 in February. We were excited about that. Sadly, it overlapped with a very unfortunate period in humanity's history. And so our party will be delayed, and we'll do a happy turning 6-year-old party next year. But as we turn 5 as an SME, we got through that valley of death of a startup turning into an SME, and how do you survive past the 5-year mark. Part of that is identifying what our core value is. And across all of our strategic planning, internal, external, with members and directors, it is very clear that our agencies are asking us to lead and spearhead a joint procurement, because there's safety in numbers, there's safety in sharing data, and it's very hard to herd cats across the country, in the sense that there is data coming up from pilots all over the place, but not one common place where all that data goes to get shared and feed into an efficient evidence-based procurement. So we are taking that duty on because it's been asked for. It's something we do well, and it's something we're learning to do, and it's something we'd like to execute on, and we've partially executed on it in our eBus phase 1 project. So we have some experience to build on. Therefore, this year we will be developing and leading the development of a memorandum of understanding with a group of 4 to 5 cities. We right now have about 10 cities that have put up their hand, transit agency or city, that have said they are interested in a common procurement, but interested based on what the conditions are going to look like and whether we can move forward. That was pre-COVID, so we're going to go back and do a new survey of folks post-COVID, see is the interest still there. I believe it is, and possibly even greater so. Getting to about 30 to 40 autonomous shuttles and connected shuttles for that first kilometer, last kilometer, and looking at a joint procurement that may integrate a leasing environment. And so this could be the development of a joint procurement where the procurement is not asset ownership, but it's asset leasing or some innovative financing and leasing model that sees the outsourcing of the asset ownership as well as the operations and maintenance, given that the operations are going to be very heavily digitized in nature and virtual in nature, requiring a sophisticated virtual control room for safety, security, and addressing user sentiment, dissatisfaction, or concern, as we articulated earlier. These are not skill sets that transit agencies have right now in terms of a virtual, real-time, on-demand, high security, high fidelity, low latency, digital robots moving across cities, managing those in real time. We do not have that capacity in our transit system right now. So if we wanted to do this at a large scale, like an integration trial, we would have to bring in that operations and maintenance through partners who have much more technical competence in doing this than the way that our transit agencies currently operate their buses. And the goal could be twofold. One is that that knowledge is eventually transferred to transit so they can operate and maintain. Some transit agencies have a great deal of experience, like TransLink or TTC or STM in Montreal, but not all transit agencies are at that level of asset operations. And so those agencies that are not necessarily at that level or with those resources or those staff may need a transfer period. So phase 1 is outsourcing of those operations with an intention to train and learn, or it's with the intention of ensuring that these things are always outsourced because it's much more efficient from a technology standpoint for it to be outsourced. And it's not outsourcing driver applications, it's outsourcing the movement and digital control of roboticized, automated, and connected vehicle people movers. So that is a dialogue that we're in the midst of, and thus thinking about how to bring financing into the table, rather. You could think about some of the designers and manufacturers of the products actually financing their own products over the course of the life cycle of these vehicles, chargers, and system design components. There is a goal of integrating eventually an on-demand platform provider. That was a live debate we had last year. A lot of transit agencies saying, look, we want to move to on-demand. On-demand of unconnected or rather dumb units is interesting, but it's not where we play at CUTRIC right now. So lots of cities going to an on-demand platform, that is great and innovative, and maybe we will play in that space. The on-demand component of automated connected vehicles is not there right now either, because you're talking about these shuttles going off-piste or off-route on demand, like a taxi service. We could maybe eventually get there. Where we do think that we could integrate this on day one is if we have dedicated or semi-dedicated laneway. And I'll use the King streetcar example. Let's say there's a fixed route for these shuttles and fixed schedule for a period of the day. And these shuttles are operating in between streetcars that are driver controlled, that carry a certain capacity, but you don't need another streetcar operating. You need a streetcar plus 30% of a streetcar. Maybe the shuttle can solve that. So the shuttle is following the streetcar in a fixed fashion, picking up additional people, trailing or platooning the streetcar. That could work. Now imagine it's not the peak period. Imagine it's 2 o'clock in the afternoon or it's 9 o'clock at night and the streetcar is not coming as frequently. I'm standing at the station stop in the middle of the night. Could I on demand request a shuttle that is located at either end of King Street to come and get me off its normal schedule? Yeah, I should be able to do that. That we should be able to integrate into this project. That should be possible to do. We have a lot of dialogue ahead with our manufacturers and platform providers to see if that's possible. So it's something that we have started to come up with as semi-on-demand, and that was a phrase that Mahmoud came up with. I thought it was very smart. So we're looking at not full on-demand, but semi-on-demand integration of a platform capacity to request on the dedicated or semi-dedicated laneway the shuttle when it's not operating in its peak or fixed route service. The goal of this project is that we are designing the MOU, and we have the coalition, the willing, and we have the funding or financing arranged by the end of this year, or drafted to the extent that by early Q1 2021, we're moving into procurement dialogue. And that those procurements turn around within a year period. We're assuming at least 12 to 14 months for manufacture, design, civil works, build out. So we're looking at about a 2-year time frame from today to get to procurement, for these things to show up on your streets, for you to integrate, test, commission, and launch them. And then we're looking at these things being at least 5 to 8 years in length, being monitored, modeled as this integration trial. And the reason we say 5 to 8 years is because that originally were the lifespan of the shuttles that were being shared with us. If that lifespan has extended, and it could be 12 to 18 years, like an electric bus or a regular bus, then we would expand the life cycle of the project, because the intention is not that it's a shuttle here today and gone tomorrow. The intention is that it's part of the permanent fleet. But if it is leased and outsourced, it's possible that the outsourcing framework, the collaborative framework, is a 5-year framework. So the dedicated laneway may be built out as part of phase 1, but after 5 years, based on performance measures, the city or transit agency may decide that 5 years is the ticker when the city should have the ability to switch providers. Maybe they're not happy with the manufacturer's offering. Maybe they're not happy with the on-demand platform provider. Maybe they're not happy with the private consortium of partners that are operating and maintaining these shuttles in the first 5 years. And performance measures will prove that out. So there's a ticking scenario where 5 years comes around and the city has the right to renegotiate who operates this system. But the overall goal here is that these are not one-off pilots. They're not here today, gone tomorrow. As I said, that these are part of a permanent fleet movement to first kilometer, last kilometer. And the objective is absolutely to increase ridership in transit, and to increase employee mobility if it's airports. So definitely part of the performance measure has to be, can we increase local transit ridership? Can we also decrease local car usage to the first endpoint and starting point? That is the goal. Our goal is not to attract the automotive sector to come to a new city to invest. That, if you go back to 2016, 2015, literally city councils were saying that if we launch an autonomous shuttle, the auto sector will come to us. It didn't happen, and it won't happen, and that shouldn't be the objective. The objective here needs to be moving people in a low carbon fashion to improve mobility for Canadians. That is our objective and will always stay so. And at the airports, it's about moving people so that if they're getting to the airports by transit, they're not struggling to get to their place of employment, which happens in a lot of our city airports. Very difficult to get to the airport by transit. And if they're driving most of the way, that they are not struggling in a safe manner, efficient manner to get from the place of parking to the place of employment. We'll go to the next slide. Just to summarize on some of the final parameter conditions that we want to articulate here, we're not going to go too much into detail around the P3 that we started to pontificate a little bit last year, as it looked like money for green investments was drying up in terms of pure cash and pure funding. We were really looking at pulling something together that the Infrastructure Bank of Canada might be interested in as a triple bottom line winner. Even though it's not a $1 billion project, it's in the several millions or dozens of millions of dollars. So really an innovative P3 model that allows for a public-private partnership in technology integration, deployment, discovery, learning, and fleet integration for low carbon goals and mobility goals. We're still on that pathway because, as I said, per my original points, the money and the stimulus money won't be there forever. There will eventually be a taxpayer reckoning, and we have to figure out what can we afford now, and if this is a multi-phase effort to improve the technology and the systems integration. In 3 to 4 years' time, we may be back at the table talking about a phase 2 integration trial with 20 cities rather than 4 or 5. So we've got to keep this thinking alive. And in fact, even in a landscape of a lot of funding, it may make more sense to still have a public-private partnership for a whole host of operational, maintenance, digital control, and performance measures reasons. Go to the next slide. In terms of some of the engagements here, the vehicle manufacturers are at the table, the vehicle operators are at the table, the data analysts are at the table, including our own data analyst team, and the roadside infrastructure folks have been at the table in our planning process. Going forward, these are some of the core entities that are at the table that need to be at the table in designing something like an effective public-private partnership. We'll go to the next slide. With that, it brings us to the end of the whirlwind tour of updating you as to all the work we put into place in the last 2.5 years to try to figure out what's going on in autonomous connected vehicles. What role can they play in transit? Where do we need to privilege them as a transit or shared mobility solution? Where are the pitfalls and the problems and the boogeymen in the closet that we now need to flesh out and bring out and discuss and deal with because of multiple years of pilot projects? And now where can we partner, like with the good folks at the City of Toronto and TTC and Metrolinx, in moving towards joint procurements that get us beyond the valley of death of one-off pilots? That's where we are now. We wanted to share with you all of our knowledge that has driven our decisions to date, so that for those of you who are participating in this effort and have been, you're not shocked and surprised as to why we're talking about level 4. And you're not shocked and surprised as to why we're talking about redesigning the urban landscape in minimal fashion to support maximum benefit here for semi-dedicated, dedicated laneway. And you're not surprised when we say we're going the DSRC route, because we don't need 5G to solve this problem. We do need roadside units though, and we do need some DSRC support and connectivity. So none of this, therefore, we hope will surprise our members or our partners as we start to move forward in this integration trial that we believe, based on all this evidence, would be best delivered through a national joint procurement where we hold hands, share data, and have safety and security in numbers, both for procurement and operations and maintenance. So with that, we'd identify to you some of our upcoming sessions. At the next session, we're really looking at the empirical evidence from Calgary plus a few others. I think we're going to invite our colleagues at the City of Toronto to also elaborate upon their lessons learned through the procurement process. That is like gold. I think we all need to hear that, and it's definitely the kind of information we need to feed into our own procurement process. Then we'll be looking at the on-road testing. So if we get to this MOU environment, we're going to have a series of cities identified. We'll have identified the pitfalls of past procurements and deployments. That's going to feed into a tech spec. The big unknown right now, after all these years of effort, is which certifications do they need to be designed to? So for our manufacturers, per Robert's point, not all will be able to accommodate the certification and cybersecurity specs that are built into this common procurement. And that is critical. And then the signing of the MOU. In our e-bus experience, I'll just let you know, I don't want to, throw a bouquet of roses your way when actually what I need to show you is, a handful of weeds. The MOU takes a long time. In our e-bus experience, it went through 17 drafts to get to the MOU. And then once we got out of the MOU, that MOU was core and critical. It helped us to work with Novabus and New Flyer and ABB and Siemens and 3 transit agencies and utilities. And we were able to always revert to the MOU over a period of 2 years of procurement to make sure everybody was in line with the spirit of the MOU when things got really tough from an engineering, commercialization, or business standpoint. And either manufacturers or integrators or utilities or transit wanted to change some of the specs in between for political or for commercial and business reasons. And the MOU tethered us and held us all to have to deliver on the specs embedded in that MOU. And as a result, we got a world-class trial out the door with a lot of lessons being learned about electric busing. We want the same thing here, but it's not going to be an MOU that's passed in 1 or 2 meetings. I suspect it's going to take 20 versions, which means our project management team is going to be spending a lot of time in Q4 from September to December going through version after version with our partners. And between September, October, and December, there will probably be at least a dozen meetings just to deal with the tech specs and various aspects of it to get to an MOU execution December, January of this year into next year. And by October, our original plan was, the original plan was by December. Now it's moved up to October. The full federal funding or financing option, that doesn't mean we're waiting till October to put in bid arrangements. Over the next 3 to 4 weeks, as we've submitted already economic stimulus proposals to the government, we will be submitting high-level proposals around this and then proceeding through with the government over the next couple months to get those proposals in front of the right ministries where this will have an impact on them achieving their long-term mandates regardless of COVID. And by that, I mean this government is not going anywhere on climate action. This federal government is staying steady on climate action. That's evident. They're certainly going to be focusing on low carbon mobility. That is evident. public works that serve that purpose. That is evident. And so we want to make sure we're giving them solutions to do that. And that is our goal. It just might take, we believe, until about October, November to sign the deal or to get the confirmation of the particular type of funding in what particular cities, depending on cities coming to the table with their particular aspect of collaboration. So with that, we'll go to the next slide. It's just a series of, we have one last question, series of questions that have cropped up rather. And there are a couple questions here, John, about, rather we answered that one about passengers, but I'm going to answer Lauren's question about what would the revenue opportunity be for the P3 analysis. So in our electric bus and fuel cell bus project, when we're looking at P3, there's a number of revenue opportunities, both for the manufacturers as well as financiers that may have no role in manufacturing or integration. And it goes from everything of interest on the financing that's provided through to some kind of equity stake, through to some kind of fee for service component embedded within it. And so in this scenario, we have hypothesized a whole bunch of possibilities. At our next session, Lauren, we're going to dive a little bit deeper into what the revenue opportunities could look like for manufacturers, integrators, possibly utilities, though less likely in this environment. That's much more likely in the e-bus environment, and potentially any other financer that's not actually technically involved in the technology deployment. So we'll continue to develop this out, but we welcome your input. If you have particular experiences you've gone through where you would suggest that there's a very clear revenue opportunity that would drive this forward. So more to follow on that question at the next session. If we go through to the last slide, we just want to let folks know we have not canceled our conference. Right now, as many of you know, our second Canadian Low Carbon Mobility Tech Conference, focusing on zero emissions transit, so ZEB, e-bus, fuel cell bus, and autonomous smart shuttles with the data component, scheduled for June 17th to 19th in Winnipeg. We are still going forward, but not in Winnipeg and not in person. We are going virtual, and we've virtualized everything. The last 3 weeks has been a hustle to get the best platform that we can get, to get the agenda set up, to get all the speakers and keynotes on board. We've just about finished that process this week, so we will be formally announcing by next week the virtualization of the conference. We've also had lots of folks ask for more sessions on transit and COVID innovation, pandemic innovation, asset mobilization innovation. And going virtual actually gives us the ability to do French sessions and English sessions without needing real-time in-person translators. So I have to say, in face of catastrophe, we found a lot of opportunity. And for transit agencies and cities, there is no doubt that this information is still needed. Most other organizations have canceled their conference. We are continuing with ours because the dialogue is simply too important. The information is simply too necessary and too needed to be delayed into the fall. So we're continuing. You will get more information about that. Lana, I'll just ask you to go through to the next slide to identify to folks in that conference. There are 4 pillars that were originally proposed. They remain consistent, and we have a full agenda around this already. Getting to zero emissions with battery, getting to zero emissions transit with hydrogen, getting to smart and smarter vehicle systems for first kilometer, last kilometer, per what we've just spoken about, and big data systems for optimization of big data analytics within transit and shared mobility. There will be a 5th pillar noted and added around pandemic and catastrophe, asset innovation, asset mobilization, and innovative thinking and planning. So with that, we've come to the end of our tour of information and updated you all. I'll note that pretty much everybody stayed on the line throughout the entire thing, so we really appreciate your attention, and we're really happy to be able to share this knowledge with you. I think this is going to be one of the most important projects CUTRIC has ever launched, has ever designed, and has ever invested time and effort into. It's complicated, it's going to be messy, and it's going to be hugely beneficial to Canadians once we get it out the door. So I'm happy to be able to work with a brilliant team, Elnaz, Mahmoud, Carla in Quebec, and Lana in Alberta, to be able to move this forward for the sake of humanity and also the sake of all mobility users and riders, and those folks who don't know, but who eventually will know they will abandon their cars because the technology we deliver is going to be better than their cars ever could be. So thank you very much, everyone, for your time, and we look forward to seeing you at the next session. A presentation version of this and the live recording will be provided online shortly and disseminated to all of you if you'd like to go back and review these materials. Stay safe, stay sanitized, stay psychologically sound if you are isolated as I am and many others are, and we look forward to connecting with you virtually in the near future.